It'll take me a little while to warm up to this because I haven't done it for a long time. But so the publication, you ready? The publication was the Tesla and Alexanderson system of radio. So I'm going to work on that, and then I got to work my way out so that you know what radio is. And did you bring my book, George?
It's right here.
No, a big one with all the pictures in it.
I did not bring that one.
Uh-oh. That has all the pictures.
Needed that.
Okay, well, we'll do without them.
I can send Catherine back for it, and she can bring it back within an hour. Would that work?
No, I'll just adapt. Because at any rate, you opened up at the right places. I have to figure out some way within about 45 minutes so that everybody can understand what that page means. So how many people here know what a quadratic equation is? Oh, that's pretty good. How many people know what a differential equation is? Oh, okay. Well, that's good. How many people know what Heaviside's telegraph equation is? Oh. How many people perform or play music? Okay. How many people wrench on engines, motors, pumps, circuit breaker boxes? Okay. So it looks like everybody will kind of, I can make an analogy. So the thing is this being the Tesla Society and all that, nobody ever seems to talk about who Tesla is. How many people here know who Tesla is? Okay. How many people know why his name stands out from everybody else? Okay, so Tesla is not a complete unknown. How many people get upset when you say Einstein's theory of relativity is wrong? There, good. Okay. So what you will get is the first public presentation of the theory of anti-relativity. Okay, so Nikola Tesla was a pinnacle in the electrical engineering world, which basically doesn't exist anymore. There's no electrical research anymore. There's no electrical laboratories. No one's ever bothered to complete the unfinished equations or all the mistakes or the whole situation. So we got to kind of go all the way back in order to understand what Tesla and his contemporaries are working on. Now, you have to keep in mind with regard to Nikola Tesla, he wasn't just like a soul flash out of the blue individual that appeared from nowhere and just figured all this stuff out. What Nikola Tesla did is he rode the wave of an intellectual movement at the time. He was the peak of it, the quintessence of all the studies and theorizing and the math and everything that had accomplished with the start of a person by the name of Galvani would really be your beginning in all this. An Italian medical man that found that certain pieces of metal would cause animals' legs, if they weren't too deteriorated on the dissection table, to jump and twist. And then Galvani found that when there was a lightning storm, the legs would flop around on the table without any metal. So Galvani invented the antenna to experiment with what there was in space that made the animal's legs jump, and the detector that Galvani had at the time was the muscle tissue response to electricity. It didn't have any diodes or vacuum tubes or relays or magnets or nothing. It was just simply his detector was a biological organism that still responded to electrical stimulus. So what Galvani found was that there's an atmosphere around all metals. This atmosphere is different for each metal. It's identified with that metal. So if you have a metal of zinc and you have a metal of copper and you have two sheets of it and you have them all shiny, is in between them is an electrical condition. And this is what I'm going to have to explain to everybody so they can understand is what is in between this space. Okay, now later what happened is a guy by the name of Volta found that if he took this electrical atmosphere situation, okay, and it involved what's called an electrolyte, which is a fluid like salt water or lemon juice or something either strongly acidic or alkali, something basically corrosive. And you put this metal into a sandwich with the liquid in the form of a gauze or paper or jelly or something to hold it. Now all of a sudden this electrical influence can be conveyed from one metal plate to the other and produce fire. By putting a piece of metal across, you start to get fire. So what Volta did is he started compounding these little what are called cells and getting a higher and higher and higher amount of this electrical condition until eventually he could produce a standing electrical flame. Now this was the first time that mankind has ever been able to produce a continuous electrical discharge condition, because previous to that it was either permanent magnets, which you can't really get any electricity out of, and electrostatics, which you can't really get any electricity out of. And the reason is you can't have electricity until you have its two components, which is either electrostatic or magnetic. Now, when the chemical cell was developed by Volta, now was the condition where not only did the atmosphere of the metal create the electrostatic condition, but the current flow through the metal of the chemicals trying to readjust through the dielectric or the electric medium, electrolyte, and the metals produces a current flow. Okay, of course, none of these people knew what any of that was back then. So a man by the name of Michael Faraday made an extremely important discovery that basically initiated the entire electrical age, and very little has changed since Faraday. Faraday found that in experimenting with this voltaic battery, as it's called, a battery, the word battery means like a line or a compounding of things. So a battery is a number of cells, a battery of cells. So if you have the thing that you put in your flashlight or your radio or whatever is not a battery, it's normally a cell, and then you use a number of them to make up a battery. So Faraday experimented with the battery and the wires and making the sparks, studying the sparks, and then what he found is the compass on the table, pointer would move every time he was drawing the sparks. And what Faraday found is that magnetism was appearing even though there was no magnets. And that was the beginning of what we call electromagnetism, which is the basic foundation of all of our technology, to the point where it's become almost like a religion. It's a social mind virus, so to speak, or an icon, archetype. And everything is based on this electromagnetic mind reality. So what Faraday theorized was, if the compass is sitting on one place on the table and the inductive device that produces the magnetism is on the other end of the table, what is there in between? And this is where the understanding of electricity evolved from. So Faraday experimented, and he found, now how many people here have ever been like in a school classroom where they take the iron filings and they put them on a piece of paper and you put the magnet underneath? Okay, good. Most people have seen that. Well, the iron filings form little fibers. You notice they tend to bind together into a fibrous structure. So what Faraday concluded is that there was a fibrous structure in space that was responsible for action at a distance. Now, at the same time, you had Isaac Newton, who was claiming gravity worked through nothing. There was no intermediary field, and came up with the concept of action at a distance. In other words, action at a distance means you can affect an object at a distant point without anything being in between. Well, there's something nonsensical about that. What's that?
If you believe in God, you can have a science like that.
Well, okay, I suppose. But at any rate, it didn't go that way. So the conflict broke out between whether there was something in between or not in between. So Faraday came up with the idea of what's called the ether. The ether is a spatial medium, what Tesla referred to as an ultra-rarefied gas. And actually, when Mendeleev worked out the periodic table of elements, he postulated through the use of the periodic table of elements it was possible to predict elements that were not yet discovered because of the harmonic sequence of all the elements. And this led to what we would call the pre-hydrogen elements. So it seems to be there's some kind of primordial atmosphere that permeates everything, and that's what Faraday theorized it existed. And is referred to as the primordial ether. And the ether, when it becomes polarized through some type of hydrodynamical process, like twisters and tornadoes and vortexes of water going down holes and what have you, that these lines of force were appearing in this ether. If there was a a motive force or something to cause this to want to exist. It's a condition of imbalance in a normally static ether. So it didn't go too far with that idea until the telegraph guys picked up on the fact that what Faraday had also found was if you take this wire that you drew the fire with and the compass points towards it, well, if I take that wire and I compound it on itself once, twice, 3 times, 4 times, each of the current flows passing over and over give the effect of a higher current. So if I have a current of 1 unit flowing through a wire, if I take that wire and coil it around so that every part, the wires that are going in the same direction will be 1 amp, 2 amp, 3 amp, and if I put 100 turns of wire on there, I have 100 amps. Now I have a magnetic field that makes iron jump around on the table, not just compasses. And this was the beginning of the electric motor and the telegraph relay. And the telegraph relay kind of had a weird start in all this because it was developed by a painter by the name of Morse, who knew nothing about electricity, but enough experiments had been done that it was now known that electricity could be conveyed with a transmission structure from point A to point B. A monk in, I think it was France, did the final experiment of connecting the entire town's folks together, hand to hand with 25-foot pieces of wire in between, and discharged a giant electrostatic condenser, which at that time had just been developed by Franklin. And everybody jumped simultaneously. They made a line 1 mile, and everybody jumped together. And at that point, that was the final proof that electricity was then thought instantaneous and can be conveyed to any point. So people worked with it and fooled around, and then Morse came up with the initiative that he was going to push it forward and do it. So what he did is enlist the help of Joseph Henry, which was basically duplicating Faraday's experiments here in America. He's also responsible for starting the Smithsonian Institute and a number of other things. He's kind of a forgotten American scientist. And they worked together and came up with the relay coil that would pull the sounder or the key or whatever it was that you were trying to signal from point A to point B. And then they worked out the wire process. So it turned out to be you have to have in electricity what's called a boundary condition, where the wires enclose completely the electrical situation, and then once you have that, which is called a circuit, then you can get the batteries and the electromagnetic thing to work in a circuit. Now, a guy in Germany by the name of Steinhill decided that, well, let's see if we can use the Earth as the other boundary. In other words, the grounded telegraph line. Of course, all the experts immediately said the Earth is so giant it will just absorb up all the electricity and it'll never work. I mean, after all, that makes absolute sense. But Steinhill did it anyway. So he put the whole thing together, and lo and behold, it worked just fine. And not only did it work just fine, but a lot of stations didn't need batteries anymore. So instead of the electricity disappearing, the electricity was appearing. Then the question had to be, well, where was this electricity coming from? So being that the Earth was being used as part of the transmission structure, the Earth inside is a massive reservoir of electricity, and it's in constant motion, usually in some type of impulse form of waves ringing and echoing and bouncing, and there are literal seas of electrical current, rivers of it, flowing from one point to the other, and that's what gives the Earth its magnetic field. It's this incredible current flow. So that started to do more and more of these problem things started to work their way into the telegraph situation. So it started to be that in the telegraph offices, on certain days, the telegraph sounders would just be clacking away on their own, like the ghosts were operating them. And what it turned out to be, what the problem was, is the Earth was being impacted by solar flares, and it took basically the telegraph business to determine a lot of things now that, you know, is considered general scientific facts. It was the telegraph that forced most of these things to be analyzed and discovered, was the problems. So then they started to get a better idea of inductivity and antenna type considerations. And so they had to use like pairs of wires, and they had to go back to the original closed circuit during magnetic storms, which cut the number of wires in half, but that was the only way around it. And there was a lot of scientific study done during that period to determine what are called telluric currents. This is what my whole earthquake system is based on. This interference becomes the signal rather than the noise. But I'm not going to get into that. This is a specialized deal. I'm trying to cover the Tesla thing. So, but at any rate, the next problem is now they got the idea that they're going to string telegraph cable from England to the United States. And that just opened up a giant can of worms. So at that point, it took several tries to get the wire to go across without breaking. There was no math, there was no engineering, nobody knew what was going on, nobody knew what they were dealing with, and it consistently didn't work and failed, and eventually they got it going. And then an archetypal situation in electrical engineering history appeared out of this that basically formed electrical engineering. At that time, the knowledge of electricity was being heavily advanced by a guy by the name of James Clerk Maxwell, who is basically the center figure in most of your modern, like, relativity and Einstein and electromagnetism. Most of this ties back to Maxwell. Maxwell made a discovery that just kind of twisted everybody's brain inside out. Maxwell was the first person to figure out how to use what's called the Newtonian Leibniz calculus, or what do they call it? They called it, there's a name for it, like elementals or something, where you reduce the points down to zero. What's the infinitesimals? It was the system of infinitesimals, which is kind of like Alice in Wonderland. You have to believe that something continues to exist even though you divided it all the way to zero. But the important thing is it gave the engineers and scientists a way to quantitatively study the condition of change. And it introduced the dimension of time into the study of natural phenomena such as electricity. That was probably one of the most important things that led to the ability of electricity to be engineered rather than just some weird thing that weird machines made that never really did anything other than shock people, and you couldn't do anything with it. It was just toys. It was basically, if you look at the situation in Europe, you have what's called the age of clocks. It was a concept of time was emerging, and where its effect, or how would you say, maybe its conjugate or its relation, really appeared was in the music of the time, which basically comes to a peak with a guy by the name of J.S. Bach. Because basically, when you analyze the structure of the music of J.S. Bach, you see all of your engineering math and situations and the things you're going to deal with in electricity are all basically mathematically fully developed. None of the experiments or the dimensions or any of that stuff, of course, ever went with it. It was pure music. It was a mathematical expression, so to speak. Then after all that kind of got shut down, Bach was basically the Tesla of the music world. When he died, his stuff was destined to go to the junkyard. It just happened to be some guy by the name of Forkel pulled all the stuff out of the scrap heap and got Bach's work, which was all going to the dump, back on a table or in a shelf somewhere so that other people, most notably Albert Schweitzer, could put it all back together again. But that's kind of diverging. So after that point, then the Newton and Leibniz and the mathematicians started to come up with things that change with respect to time, like the gravitational situation. The thing is when something falls through space, it doesn't fall through space at a constant speed. It keeps going faster and faster and faster. But the thing is how does it go faster? What's the rate at which it's going faster? The culture was starting to get the idea of how to express these changes in an abstract dimension, a dimension of time, rather than a dimension of space. So this dimension of time led to what's called Faraday's law, which is how much magnetism is appearing or disappearing with respect to time. I'm going to kind of concentrate on the physics of all this stuff. I'm just right now trying to give everybody an overview of what I'm talking about here, and we're getting through the history up to Tesla. So what Maxwell found is the way the physicists dealt with electricity was the amount of force that it induces on matter. So electricity was measured with scales, just like mass. In other words, if you have so much magnetic force, then it pulls the scale or pushes the scale a certain amount, and that's how you measure electricity. That's how most of your voltmeters and amp meters all worked afterwards when the electrical age was established, was the amount of force delivered against something like a spring. And that was the determination of what type of electrical quantity, what its magnitude was. So Maxwell found a very interesting thing. He found that if you take a certain quantity of the magnetism and a certain quantity of the dielectricity that exists in the space between the magnets and the coils and the whole thing, is it always comes out to be the same numbers. If you multiply them together, it always comes out to be 1 over the velocity of light squared. So Maxwell theorized that this velocity of light must somehow have to do with what he was trying to discover, which was radio. Maxwell wanted to figure out a way to communicate electricity from point A to point B through this primordial ether and the electrical lines of force. So at that time, I'm not quite sure on how they determined the velocity of light, but it would have been through Maxwell that these things were probably discovered. Now, these so-called famous equations like E equals mc squared that we attribute to Einstein and all that are basically all really attributed to Maxwell. These other people just reused the stuff to, make their theories work. But it all basically came from Maxwell. So Maxwell theorized 2 types of electrical propagation through space. One was electromagnetic, and it had to propagate at the velocity of light. And the other one was dielectric. And it became complicated to ascertain what kind of velocity there would be. So Maxwell had to come up with a conjugate to Faraday's law, which could be called the Maxwell law, but it's never expressed this way in the history books. So Maxwell gave enough quantification to the behavior of electrical fields and forces that now people that were physicists who could identify forces and scales and mass and all these type of things had something to work with. And telegraphers were the first ones that were out there that made something that they didn't know how it worked and were hard-pressed to have somebody figure out what in the hell was going on, because the more they would try to develop the system, the more it would resist them. And then when it came to the undersea cable situation, once the thing was all hooked up, they found out that the telegraphic impulses would fall head over heels down the line and come completely scattered out the other end, and the whole thing was a complete disaster. So the physicists came up with an explanation and pounded on it in that direction, which is called the diffusion theory. Now, if I take an iron bar and I take a torch to it on one end, okay, and that end starts to get red hot. If I go down that bar, the bar is getting less and less hot, okay, and there's a curve to that. It's a diffusion, where the heat is scattered and conducted, and it causes a very characteristic mathematical curve that has to always be the same shape. So the physicists concluded that the electricity propagating down the cable in the form of current and a magnetic field had to propagate in this way, so they attempted to load the signal to deal with that liability the best, which was the wrong direction to go. So some crazy guy by the name of Oliver Heaviside starts engaging in experimental mathematics because the Maxwell stuff was basically impossible to use. I don't think that anybody this day has fully comprehended Maxwell's work, or I don't think anyone's even bothered to read it. It takes years. It's incredible labor. So it's just not happening. So Heaviside took some of that stuff and decided to experiment with it. And Heaviside kind of detested the calculus situation and wanted to come up with a basic algebraic expression that was easily soluble and not all these incredible differential equations and partial derivatives and the things that was just too hard to deal with. You just couldn't apply it to a working situation without twisting your head inside out. So what Heaviside theorized the problem on the cable is the cable is in reality propagating not a magnetic wave, but is propagating an electromagnetic wave. So the electromagnetic wave, having 2 parts, had 2 basic waveforms that had to be kept in match. So Heaviside solved some of the Maxwell's equations to come up with the famous equation in electrical engineering called the Telegraph Equation. You got it. Okay, the Telegraph Equation turned 20 pages of Maxwell's work into one simple algebraic expression. I'll write it down here on the board. And that's the first term, the second term. Let's see, let's go to positive one. I'm going to this way and this way. This is called the real part, and this is called the imaginary part. That is the archetypal expression of all electromagnetic activity. Everything evolves out of that equation. It's called a wave equation. What it represents is a second order differential. This one is per time squared. This one's scalar. This one's per time, and this one's per time. Everyone that works in electronics recognizes this as the RC time constant. In other words, RC equals T. But there's a lot more to it than that. So what Heaviside found is applying this equation to the situation on the telegraph cable is you had two basic waves. You have the magnetic and you have the dielectric, and then you have the rate at which the wire eats it up, and then you have the rate at which the insulation eats it up. So the problem is the wire eats up the energy faster than the insulation eats it up. So when the magnetic is propagating down the line, it's getting eaten up faster than the dielectric propagating down the line. So what Heaviside did is, being that magnetism was being weakened, Heaviside used iron wire or a magnetic tape in the cable to raise the magnetism to the point where it should have been. Two dissipations were equal, and then all of a sudden all the signals came perfectly clear out of the other end of the line. And this was just simply unacceptable to the Royal Society in London and the people who were running the telegraph business. So they just hounded him right down into the grave. But he wouldn't die so quick, and he wrote a giant 3-volume book on the whole thing and came up with almost every electrical equation and term that we use today. The words Maxwell's equations, which comes out of everybody's mouth, is in every basic book on electrical engineering, are Heaviside's equations. They have nothing to do with Maxwell. He was the one that developed the symbolic math of the curl and the divergence and all that type of stuff. He was the one that basically laid what he said, he got the baggage off of Maxwell. And then electrical engineering from that point on was made possible. Then somebody followed him, because Heaviside didn't like teaching people. And the more complicated he could make it, it seemed like the happier he was. And his books have got little stories about mishaps of people that believe wrong theories and parables, and they're not like your normal engineering book. The guy was what was known as a first-rate oddity. And he was always half ready to eat out of garbage cans. He basically, when he died, part of the reason why he died is because the neighbor kids stoned him with rocks every day, so he couldn't get out of his house. So Heaviside got to meet, like everybody else, the wonderful world of electrical discovery. So if you go through all these inventors, you find out that electrical study really is the tale of Prometheus. You will be rewarded. The eagle will peck your liver until you die. So that's the way it works in the world of electrical discovery. Not a business I recommend anybody get into, unless maybe they've been in the Marine Corps for 16 years. So what happened was another guy showed up by the name of Steinmetz. Now Steinmetz is where all of a sudden it came into basic, hardcore reality electrical engineering with nothing really half done, or there was no jokes, or any of that. And the reason for this, the reason why Steinmetz didn't get screwed with and got away with everything, as long as it was well hidden in algebraic equations and never said in English. The guy was smart. The books he wrote, the three major books he wrote, comes up to about 1,800 pages. Some of the equations are as much as 20 pages long. This guy really got into depth. And the reason why he was allowed to is because of a guy by the name of Nikola Tesla. Okay, there's a whole other class of electrical people, and the most famous one is Edison. Okay, as far as power lines, circuit breakers, fuses, microphones, basic motor generators, batteries, all that type of stuff really was, Edison was the one that pushed it all forward. So Edison's start was a telegraph operator. So Tesla was considered probably the world's best railroad telegraph operator. He could send for days at 30, 40, 50 words a minute and receive and just put everybody underneath the table. And Edison was a kind of an American folk Faraday. In other words, he had no allusions to any higher spirits or higher human causes or, saving the world, any of that type of stuff. Edison just wanted to screw around with stuff and see what he could do. And he started this at a very early age. And what he did is he attached himself to the railroad to the point where they would always give him space on one of the cars or the caboose or something to build his laboratory, until he ended up usually starting a fire from battery electrolyte experiments. So eventually he was grabbed by the ears and flung off the train, and it damaged Edison's hearing from that point on in his whole life, which further endeared him to the telegraph because that was something that he could hear easier than voices or any of those type of things. And a lot of his work was in the area of sound development. He developed the microphone that's used in the telephone today. He developed the phonograph and a number of those sound devices. But Edison decided at an early age, let's see, I got a picture of him there. Where's the main, let's get pictures of these people. The pictures of Edison and the ones that you don't see. You always see these people when they're old and bitter, after they've been screwed from all directions, and they're hissing at the camera. But here's Edison when he invented the light bulb. Whole different guy. So Edison decided that the gas light thing was just too much. The soot, the explosion hazards, all the complications. He was going to figure out a way around it. So it just happened to be at the time that people experimenting with these voltaic batteries had managed to get flames big enough that they were able to produce light. So this gave Edison the inspiration of producing an electric light. And at about the same time, it was found that if you made the voltaic flame with carbon, it would produce a bright light. And so the street lights were already, gas street lights were already doomed, but the arc light was useless for the home because it was high voltage and it still burned and hissed and carried on just like the gas flame did. So Edison came across another experiment in Europe where people were using platinum wires heated to orange heat inside vacuum bulbs, and they were starting to get an electric light. But if you got it to any usable light, it just kept melting. So Edison and his crew experimented and experimented and experimented and experimented with everything they could find on the face of the earth. They tried every metal, every combination, everything, and it was always the same deal. Once you got that thing up the white light, if it lasted for 5 minutes, you were lucky, and it went dead. So Edison, ready to give up, just about sick and dead from the whole ordeal, somehow got a hold of a bamboo fan and was looking at the fibers and playing with them and got the idea that if he cooked one of those fibers to the point where it turned to carbon, and the fibers were so strong that it still sprang like metal, that the carbon, which naturally wants to go white hot, would just make a natural inside filament for the light bulb. And sure enough, it worked. Gas companies didn't like that. Okay, so needless to say, the gas companies were not his friend. So Edison, trying to get the city of New York to adopt electric lighting system, of course, immediately comes up against the gas companies. And they have every trick in the book to try to put them out. So what the gas companies do is, okay, New York wants electric lighting system. What the gas companies did is they petitioned the city to force Edison to put all the electrical underground, which absolutely no technology existed for, because the only electrical technology was the telegraph wire. In an Edison situation, instead of being a little 8-gauge iron wire, it had to be a 2-gauge piece of copper cable. So how was he going to make all this go underground? So Edison didn't give up. So what he did is he took pieces of copper pipe and soldered them all together, wrapped them in rope, poured tar into cast iron pipes like sewer pipes, into what are called Edison tubes. They actually used to be, when they dug up downtown San Francisco to build a financial district, all the old Edison tubes came up out of the ground. And that's what they were. They were iron pipes filled with tar with a copper pipe in the middle. So Tesla set up this network of electrical plumbing under all the streets in New York City. Okay, got enough subscribers for the lights, put the whole thing in, built the steam-powered generating plant. None of this had ever been done before. He was completely on his own. The guy did not know a bit of any of the physics at the time. There was no volt, there was no amp, there was no ohm, there was no Henry, there was no farad, there was none of these things. That's what these people were up against. You couldn't open up the electrical engineer handbook and get your resistance tables off the wire. I mean, these guys had to make it out of zero, nothing. So at any rate, they got the thing all together. It was the first power station in New York City. It was called the Pearl Street Station. Okay, and they closed the switch and they tried to hook all the generators in parallel and it blasted. So they got it going in about several hours. They got the whole thing lit, and then hence that point, history. So now the next thing is not only the light bulbs, but now they had the idea of these telegraph relays. Now they got these things spinning in the form of motors. Edison started developing giant telegraph magnets into motors. The famous Edison motor is 2 very long solenoidal coils that stand almost 8 feet high, and then there's a rotor down in the bottom. You have these large electromagnetics, and what Edison had done was basically just amp up the telegraph magnet, because that's all there was to work with at the time. So this is where Nikola Tesla comes in. So Nikola Tesla comes to the United States. Okay, he's almost turned back because he doesn't have any money. But he has one thing that gets him in. He has a letter of recommendation from the Edison Electric Company in France, if I remember right, either France or Hungary. And Edison lets the guy in. So Tesla goes off on his rotating magnetic field discoveries and all of these things, and Edison just looks at him and, is not interested in any of this stuff. What Edison wants is Tesla to work on motors. So Tesla, because he's already starting to gain a conceptual knowledge of how this rotating electrical thing's supposed to work, points out to Edison that these big telegraph coils are foolish, that the coils are supposed to be wrapped inside the motor. And Edison said, if you can develop that, I will give you $25,000. So needless to say, Tesla went right to work on it. And in a short time, he had developed the present-day direct current motor, which is basically a square block instead of a tall column, and later became rounded off. So it turned out to be a great success, and Tesla didn't get a dime of his money. So Tesla left and was digging ditches on the street until some Western Union people came by and wanted to know if he would work with them on some of their projects, and he worked his way up, and he worked his way up. And Tesla decided what he was going to develop. He was going to come up with a motor that didn't need all the sparking and rigging and all the real fine wire on the coils and all these complications. He was going to eliminate that up and come up with the perfect magnetic whirlwind, where the rotor would spin in the ether with no contact on it whatsoever by setting up a magnetic vortex. But there was no way to conceive such a thing at the time, because basically everything in electricity was a positive, negative reality, so you couldn't make anything spin, because it could either just go back or forth. And they fought, and they fought, and they fought, and there's no way. You had to have the commutator as the carrot in front of the horse to trick the field. What a commutator does in the motor is the windings come around, there's a switch, And what it does, because the windings only can turn so far before we've been wanting to be pushed back in the field again or get stuck, the commutator switches in the next set of coils as the rotor turns around. So it creates this kind of phantom thing where the coils are always trying to go towards something, but then they get disconnected in the previous batch. So it's like a lineup around the thing. And fools the motor in the spinning, but this thing throws off all this dust and sparks, and it's problematic in maintenance, and the motors are horribly inefficient because they have to have these big magnet coils with lots of current flowing through them. So Tesla fought the problem in his head, and everybody told him it was impossible, and he was an idiot for even trying. Think about it. So Tesla was reciting some poetry one day, and then watching the sun go down, and then had this idea, because of the poem he was reciting, was talking in such a fashion that if the sun's going down here, it's got to be coming up somewhere else, and got the idea of the quadrupolar polarity, where you have two plus and minuses at right angles to each other, and you switch them. So what Tesla developed was a way to make alternating current carry around, just like the phases of the moon. And drew the whole thing out in sand. The thing appeared in a flash in his mind, and everything was invented at that point. Because Tesla could go into visions so intense that Tesla was renowned for building motors in his head and running them for months to see the rate of bearing wear. So you're not a normal individual. So we can only imagine what went on in his head. So Tesla worked with this and got it developed, but gee, nobody seemed to want it. And Edison got really upset about the whole thing. So Tesla's about ready to give up on it. He meets a guy by the name of George Westinghouse. George Westinghouse made parts for railroad trains, mostly the brake system, the Westinghouse Brake Company. Okay, now some of those brakes are magnetic. So he was already geared up for coils and solenoids and things to actuate the brake mechanisms. So Westinghouse decided he had enough money, he was going to support Tesla, and they were going to make this thing and make it work. Well, Edison didn't like this at all, so Edison turned into the gas companies. The very thing that screwed Edison. Edison repeated the whole process and delivered it all to Tesla. So what Edison did is Edison started getting reject circus animals, hiring kids to gather up dogs and cats off the street, and he would have them Westinghoused on stage, which was about 2,000 or 3,000 volts of alternating current, about several amperes. So he had to have a big machine somewhere to produce this, but that never really showed up in any of the old pictures. But what did show up in pictures was elephants just crumbling to the ground with smoke shooting out of them. So we're talking about 50, 75 kilowatts to do that.
Ouch.
The electric chair is 5 kilowatts. So you cook up a big slab of meat in the oven, you usually got to have about a 5 kilowatt cooker going for a couple hours. So that gives you an idea how much juice it is they put through the body. So Edison invented the electric chair using alternating current in order to put Tesla out of business, and then started spreading these stories of the fantastic dangers of alternating current. So Tesla was getting rocks through the window and the whole deal, and he's trying to push all this forward. But Tesla really pulled a good one on him. Okay? At this point, Tesla had already invented all that motor stuff, and he was on to something even bigger, even more fantastic. So he wasn't really worried about a lot of things other than just getting his money. So here's what Tesla discovered. Tesla discovered a completely new type of electricity, unlike DC or AC. Another type of electricity. It's called impulse electricity.
You need to stop for just.
This impulse electricity behaved in a fashion that was completely extraordinary. It was getting back into the ether electrical concepts, because what it would produce would be so bizarre that it almost looked like the aurora borealis appearing around his coils. So what Tesla found is this type of electricity, rather than being damaging to the body actually seems to benefit from it. So Tesla was destined to give a demonstration of his more recent researches. He was already famous for his motor. Okay, and Steinmetz was already put in business in order to mathematically analyze the Tesla system so that General Electric could defeat Westinghouse in the Tesla patents. So that's how Steinmetz got basically started in the thing. And Tesla built all this stuff in his head, and he left no engineering math. He didn't need any of that. So there's no way that other people could duplicate his devices because there was no engineering. He didn't know how much iron to use. He didn't know how much copper to use. People would try to use these motors, and for some mysterious reason, they would just keep burning up. And it was Steinmetz was the one that discovered why. And that made him famous and put him in his lifelong position as the founder and director of General Electric Research Laboratories. So Tesla devised his vacuum tubes and his transformers and all the things that technology that he developed with this impulse electricity, and gave a presentation in Europe. And it was so fantastic that Tesla was immediately a worldwide hit, not only as an electrical scientist, but as a magician. What Tesla had accomplished, which nobody's been able to duplicate to this day, is he connected himself to these devices that he packed over there, closed the switch, and how many people know what a neon bulb is? You know that the funny glow that covers the metal electrode, it's like a fire, but it's not really a fire, and it kind of looks like a jelly, but it's not really a jelly, but it's the plasma, the glowing plasma in the neon bulb. Tesla's whole body lit up like a neon tube cathode, on stage, without a burn or a mark on his clothes. And then he pronounced, "Here are the dangers of alternating current," and laughed. So that ended the whole DC-AC controversy right then and there. Plus, J.P. Morgan needed to make money off of it. So nothing could stop it at that point. So it went. And Tesla kept pursuing this technology. So what Tesla found is Tesla came up with a situation that kind of defeated the whole physics end of the electrical engineering world, and that's basically why there's no knowledge or information on it, because it's just completely blocked off. These things are impossible. They can't happen. But, you build Tesla's devices as he prescribes in his writings, and you will get all of these effects. I've duplicated just about every Tesla experiment. In fact, actually, I'm very famous for being probably the only person that has ever duplicated Teslas in experiments. And it's not because I'm smart or that I talk to space aliens. What it is I don't make any improvements on the historic study. It's that simple. I just do exactly as instructed, and it all works exactly as described. So Tesla had come up with a way, with this high-frequency experimenting and the mechanical analogs that he developed to go along with it, to defeat the action-reaction law, or the Newtonian law, where every force has a counterforce. Tesla came up with a way to produce a push without having to lean against anything. He did it both electrically and mechanically. So what Tesla found is that similar devices that operated on the same frequencies or rates would communicate energy between each other. So what Tesla did was basically, at that time, discover radio. But the thing about Tesla's radio that's different is there's no real energy loss between the two devices. In other words, you can transmit from one device to the other, and there's not, it's like there's nothing going on in between. It goes right to the receiving device. The electrical meter doesn't start spinning at the transmitting station until the space heater is plugged in at the receiving station, and there doesn't seem to be anything measurable going on in between. And Tesla's aim was to produce a worldwide power system that was based on this principle, and the power system would be tuned to the natural resonant frequency of the Earth, and you could just simply disconnect all the generating stations, because the solar system would run the electrical plant. It would be one with the electrical system of the Earth. So what Tesla had to do is he had to do an experiment in Colorado to prove if he could resonate the Earth and make it take off. And it's too bad in that day and age there weren't videotape cameras, so somebody could have got documentation of what this guy must have unleashed. So what Tesla did is he had figured out the frequency of the Earth, or the harmonic that he could use, which he started working at about 80 kilocycles, and eventually he worked his way down pretty close to 50 before the thing was all tuned up. It was a transformer that had a coil 50 feet in diameter. The output terminal of the thing was on 100 and something foot, at least 100 and something foot mast. And the idea was Tesla was going to send an electrical pulse into the Earth. It would bounce off the inside of the Earth and come back at a certain time with a certain increase or decrease in energy level. And he was going to continue this process, in microsecond groups as these 50 kilocycle waves are echoing in the planet, until what he would produce, it would be a giant electrical fountain of the Earth's activity at that point in Colorado, which is kind of a place where it was safe to blast because nobody would get hurt. The elevation was good, and this is the place he chose to do it. So when Tesla closed the switch, after all the experiments and tests, he produced for a period of about maybe 1 minute a standing lightning bolt at the terminal of his giant transformer in the building that contained it. Not just one pop, almost standing lightning bolt, modulated at about 5,000 cycles a second from his capacitor discharge switch. So the sound must have been something that was unfathomable to describe. Tesla succeeded in concentrating the entire electrical activity of the Earth into his station in Colorado. So he packed up his bags and moved back to New York, and in Long Island began to build the final station where this was not an experiment. It was something that worked. So he could start applying it to electrical transmission. Well, yeah.
Can I just change the tape?
Okay.
Sorry.
Just out of curiosity, are you going to comment on the spatial tether experiment? In more recent times, it's a kind of reflection on this idea.
Which experiments now?
The tether experiment, where they towed a line behind the spatial and collected this enormous amount of current.
No, basically this whole discussion ends with the death of Steinmetz.
Okay, but I just thought it was like an interesting anecdote.
Well, I mean, yeah, if there's some other, but later on, I mean, if anybody's got anything to add with any newer experiments but right now I'm taking everybody back to the 1800s. We don't even know what the space shuttle is. The whole idea is to recreate the mind of the people that invented all of this, is what I'm trying to do. And then, each person can fit it into their own, analogous, business or understanding or whatever. So, but, I've still got time. Things can go in any direction. So right now, I just want to introduce the characters. Okay, so are we back on?
Yeah.
Okay, so Tesla basically, this was about 1903, around then. Tesla was promptly put out of business. And as far as overall history goes, he spent the rest of his time as a homeless person, feeding pigeons on the street. And all the rich people that, he made rich and all that, basically just always made sure he had a place to take a shower or a hotel room. So the world's greatest electrical genius spent nearly the entirety of his adult life feeding pigeons on the street in New York City and hanging out in the library. So that's the end of Tesla. But we still got Steinmetz. Okay, now Steinmetz has taken the heaviside mathematics and developed it into an extremely powerful analytical tool and engineering tool for electrical work, and is doing things in the laboratory that are basically beyond conception. Steinmetz even has a reputation for building a time camera. So Steinmetz wrote a book in 1900 called The Theory and Calculation of Alternating Current Phenomenon. That immediately made him world famous. Steinmetz found out why the AC motors were burning up and heating up and developed what's called the Law of Hysteresis. The Law of Hysteresis is a situation where cause and effect no longer have a direct relationship. They're separated from each other. And through a hysteresis cycle, energy can appear or disappear into alternate forms. And basically, The internal combustion engine in the car works on a hysteresis cycle. The refrigerator in your house works on a hysteresis cycle, in that the cause and effect relationships are altered so that energy is transformed from one system or one state to another. Now, to diverge a little bit off of Steinmetz, but I want to get this concept in people's minds, is everybody has the usual sing-song parrot idea that inside the cylinders of the engine in the car there are explosions. Okay, and these explosions create these pressure waves that push the pistons, and then when the pressure waves are all gone, then there's no more juice left and you have to get the crud out. And there's this heavy change of pressure and temperature, which basically an explosion defines. In other words, at one point the pressure's high, at another point the pressure's low in time. First it's hot, and then it's cooled off. Well, when you start to study reciprocating apparatus, you start to find that during the whole combustion cycle, there is absolutely no change in pressure in the cylinder. Zero. So something got stuck. This is how the law of hysteresis works. What Steinmetz found is that when you have current applied to electrical system to force magnetism into existence, the rate at which the magnetism develops is not the same rate at which the magnetism dissipates. And the two, the force and the forced deal, don't tie together anymore, and they don't happen at the same time. And what this does is it causes a massive loss of energy. So Steinmetz had to figure out a way to work with only magnetic materials that didn't have the hysteresis effect, and to laminate the iron instead of using blocks, so the magnetism wouldn't be shoved into the metal, but rather be guided by it. And then lo and behold, the AC motor was entirely engineerable and possible without Tesla and without Westinghouse. And alternating current flourished at that point. Now this book he wrote, it's almost like some kind of acid trip. What it is you read, I went through all the books to try to find the equations and ideas I needed for my studies at RCA, what I'd come across, and no books worked. There wasn't any book that could give me an idea of where I was going. I read Maxwell, I read Faraday, I read all the standard college texts on electromagnetism. All of it turned out to be absolutely useless or just too much work to get anywhere. Well, Steinmetz figured out a way to turn all this just into little high school algebra equations, completely wiped out all the calculus, all the other complicated stuff, by what he called symbolic algebra, which is an extremely important thing to get into. It allows for a way of conceiving things that are not within our normal dimensional realities. This book was such an impact on the electrical engineering community that a guy by the name of Ernst Alexanderson, let me find him, because he's basically the reason for the talk. Where's Alexanderson? It's back further. Oh, I got a great picture of Steinmetz here. You got to see him too. Okay, that's when he's an old man. This is generator. We're in the right chapter, the GE chapter. That's when he started at General Electric. That was Alexanderson. Steinmetz is, when he started at General Electric, Edison. Here we go. That's Steinmetz when he first got started in his mathematician career as a radical in Germany, writing an underground newspaper. So the classic Steinmetz is, there he is with Einstein. You can see, here he is in the middle of the whole crowd. Can you, there you go, there he is in the middle. You can see his deformity. Yeah. But he was the brain behind all the rest of them standing behind him. And he always had a little smile on his face, like he knew something that nobody else did. Here he is at his prime. The cigar was a fixture. If it was taken away from him, he disappeared into the bushes, and the whole GE crew would have to hunt the woods in New York to find where the rat was hiding. So that's how he kept his situation under control where he worked, because AC was not possible without Steinmetz. So Alex Anderson got a hold of this Steinmetz book in Sweden, where he was studying electromechanical engineering, and jolted him to the point where he got on the first boat and came straight to GE Labs in New York and to stand in front of Steinmetz. And Steinmetz took him right in, and they developed a type of radio that is now like the Tesla system, but another type of radio that's of equal importance in the whole situation here. Having all of Steinmetz's mathematical abilities and knowledge and GE Labs at his disposal, the whole idea was to get around the Tesla patent. You could not develop radio unless you got around the Tesla patent. So what Marconi did was circumvent it by suing, okay, and then screwed the whole thing up into something that resembled Tesla's system but wasn't Tesla's system. But Alex Anderson, now he had a problem with GE. Not only did he have to get around Tesla's patents, but now he even had to get around Marconi's patents because GE couldn't patent anything that was already patented. So Alex Anderson developed, based on the Marconi system, another type of radio. Now this radio is not really clear how this one works. This starts to get into the fringe area of radio propagation. And the net result that's implied by the way the system is laid out, where Tesla's system kind of drills a path from one place to another and doesn't spread out, but there's still electrical lines of force of connection. The Alex Anderson system seems to be kind of a prelude to a situation where electricity will disappear in one physical location and reappear in another physical location without anything going on in between. In other words, a true action at a distance. And as far as like the conspiratorial or theory end go, I would go so far to say that two properly constructed devices based on Alex Anderson's principles, if you have one antenna in San Francisco and you have one in Los Angeles, and everything was tuned up right, that if you were standing in the one in San Francisco, you would be simultaneously standing under the one in Los Angeles as long as the generators were running. That is the implication of that particular technology or engineering, and that's what makes it worth studying.
Could you comment, if you wish, that the Philadelphia experiment might have been a variation of that?
Well, see, the Philadelphia experiment I don't know about because that's not there. You know what I mean?
I understand.
But yeah, the Philadelphia experiment would have to be, yeah, it would be something similar to that, but it'd be more like that integratron. But we're starting to get into that direction. That's what we're starting to get into. What it is what Alex Anderson had done, the picture of his patent, well, I won't get into, I'll draw all that out. Alex Anderson had done was to figure out a way to make an electric structure that is what's called scalar. In other words, there's no variation in space. If the structure, the switch is closed, the thing's turned on, if there's 100,000 volts at one end of the antenna at t equals 0, at the other end of the antenna, the 100,000 volts is still at t equals 0. There's no time delay for the wave to get from one end to the other. It can be completely neutralized. Now, the first place this was done was in a place called Bolinas, California, which is not too far away from here. This was the first full implementation of the Alex Anderson principle to completely neutralize the velocity, because the velocity in the Alex Anderson system is engineerable. It has no relation to the velocity of light other than infinite velocity and the velocity of light are two what would be called poles or zeros in the system. In other words, they're kind of like nodal points where it crosses over from one state to the other. This is what I use for my earthquake research, is I come up with an antenna that receives out of the ground in such a way that the interfering currents flowing around can't affect it because they have a velocity. The antenna has no velocity. It all responds instantaneously, so it only responds to what comes straight up out of the earth and not what's moving around in between. It could be presented another way, is you're presented with an engineering problem where you have 1 mile of ground rods with a spacing of 300 feet. What kind of transmission structure is going to connect those ground rods together so they're all operating instantaneously and one isn't late or early with respect to the other? That's the basic engineering problem. And the Alexanderson principle and the Tesla principles are the way out of these things. Now, what Tesla had done inadvertently is Tesla had created a situation where instead of plus or minus in his motor work, now he created 4 poles instead of 2. So you can't use plus and minus in its simplest form anymore because now you have 4 instead of 2. Let me see if I can get into the plus. Does this thing erase this grease thing? Okay. Well, not easy. Let's kind of get into plus and minus a little bit and see what all that really is all about, rather than something you just heard somewhere when you were 12 years old. Okay, basically, all we can do is add with our fingers. Every other mathematical concept has to be derived. As primitive organisms in this world of mathematics, we count, okay, which is a process called addition, okay, which is symbolized by the plus. Okay, so if I have one item and plus another item, I count 1, 2. So 1 plus 1 equals 2. This is something that's innate in our kind of just, animal reality. Now, where Steinmetz comes in is how we work our way out of these type of situations. So the thing is what Steinmetz decided is being that we can only add, because we're primitive creatures, if we want to subtract, we have to use what's called an operator to evoke subtraction. So what Steinmetz did is you take a minus 1 and you multiply that by 1. And if you add that to 1, then you have subtraction, or 0. And he called this an operator. So now not only, being that 1 has no real existence in the quantitative end of it, we can just say now we have the concept of minus. So he's introduced now the mathematical concepts of plus and minus. Okay, and the way we derive these type of equations is we take 1, okay, and we take what's called the square root of it. Okay, or we take 1 to the 1/2 power. And this gives us plus 1, as most mathematicians would know right off, and minus 1, because the square has to have 2 roots. So what Steinmetz decided, let's just keep carrying this on so that we can get Tesla's 4-pole electricity into equations. So Steinmetz decided, let's go fourth root of positive 1, which has to have 4 roots. So you end up with 4 roots. You end up with 2 that are the square root of 1, which is plus 1 and minus 1. And you have 2 roots which are the square root of negative 1, which is plus j and minus j. So now we have 4 polarities rather than 2. We've scaled it up. This is what Tesla visualized in his visions in his mind, but Steinmetz turned it into a very simple algebra. There's no sines, there's no cosines, there's no trigonometric functions to deal with or any of that. It's a very simple algebraic situation. Now what Tesla did when he moved from the alternating current to the impulse current, okay, I'm going to have to define these things now. This is sure a lot of work. Okay, in the telegraph days, we have what was called continuous current from batteries. In other words, as time moves forward, if we have a device which basically measures the current, it's always the same. It's always constant. Okay, and the chemicals as well as the ether move in the direction of the current and gives us the false illusion that the wire is carrying the current and not the ether in the space between. If we take an electrical condition, let's see how I'm going to go about this now. Okay, well, I'm going to stay with this. Now, if we take this current, okay, what Tesla worked with was alternating current. So now with alternating current, what it is in a constant, where this current is constant, alternating current is in a constant state of change. So that can't really be represented by a line anymore, but now it's represented by a circle, okay, which continuously moves. Okay, and if we take projections of this circle, we find that there's one piece of the wave at one plus minus type of situation that produces a kind of sideways spiral, which is known as a sine wave. Okay, but the thing is we're dealing with a circle. So what it is we got this other wave, okay, and it's moving in a contrary conjugate type of situation. So at every time the current's not zero, but there's another one to back it up, and they just keep going around the cycle, and that's what makes the motor turn. We start off with plus 1, and then 90 degrees later plus j appears, and then 180 degrees later minus 1 appears, and then 270 degrees later minus j appears, and then 360 we're back to 1, so that the piece of iron inside the motor doesn't have to be connected to anything, because now it's just simply following the magnetism around. It becomes the perfect electric motor. Now, what Steinmetz shows is if we take this direct current, okay, and we open the switch. Okay, the big problem in electrical engineering in the beginning was when you open the switch, when they built the big substations and the transformers and all that, you can't turn the electricity off. It'll blast. So now Steinmetz had a new job. Why was everything exploding? First he stopped it from cooking. Now it's exploding. When they got the power level high enough, well, it turns out to be that the magnetism and the dielectric fields have stored energy. And if it has nowhere to go, it will blast a hole to get there. So what it is when you turn off the electricity, if it's pretty much in a direct current circuit and it's not much to store electric fields like coils or condensers or just light bulbs, what it is the current has to change at some rate. It has to move. It has to go into another direction. So what you get is you get what are called transient currents or impulse currents. You get these little jolts and changes as things are trying to readjust. So if I have a current, okay, and then all of a sudden I switch that current, then I get like a spike. Okay, and that sudden rate of change is like an electrical impulse. It's not an oscillation or a cycle. It's not continuous. It's a quick change from one step to the other, and the whole electrical system has to readjust to this. So usually what happens, being that there's so much stored energy, that it starts in an oscillation, where the energy has to go between the various forms and bounce back and forth to try to get out, and it produces what's called an oscillating current, where the sine waves now are compounded with this other dampening wave, and it produces oscillating currents. Now these type of currents no longer have frequencies in the conventional sense. This has no frequency, DC. This has a constant frequency, an RPM, which we call cycles per second. But this has a different type of frequency in that you find that these curves, just like these curves always move in a sinusoidal form, these curves always move in an exponential form. And it turns out to be the same exponents that are associated with things cooling off or leaking or any type of dissipative type of phenomena. It never occurs at a constant rate, but it occurs like gravity on a rate upon a rate. And it also is a frequency of types, but it would be called an imaginary frequency. And instead of being in cycles per second, it's what's called in decibels per second. Now the generalized electric transient will be some combination of those and will produce this complex frequency. So these things were all running up and down the transmission lines and getting in the transformer coils and motor coils and starting fires, and sparks would just jump off of the lines and hit people for no apparent reason and blast them out of existence. It was a real problem. So Steinmetz wrote his second book, The Theory and Calculation of Transient Electrical Phenomena. And out of this book emerged this understanding of electricity that is so far in advance of anything today that it's just mind-boggling what this guy had discovered. And this, again, is what Alex Anderson had to work with in the development of his radio. Now, what Tesla did is in using these impulse currents and oscillating currents in his engineering, Tesla came up with another type of polarity situation where there's only one pole. That's it. In other words, it's not even the square root of 1 anymore. It's the 1 root of 1, which is just 1. There is no plus and minus. Tesla came up with an electrical device where he could connect it to something like the Earth, and it would create electrical movement in the Earth, but it wouldn't have anything else to connect to. It was a one pole. It was just simply a plus. There was no negative. There was no return circuit. Because the situation is like I explained, if you're going to transmit electricity or receive electricity out of the ground, you put in 2 ground rods in the earth, okay, and you connect these to a battery. The telegraphers tried it, and that's the first thing they found out is most electricity just goes between the ground rods. Now, if I make that alternating current, well, it's just going to be the same thing. I can make a quadrupolar alternating current, then you got 4 ground rods. All it's going to do is spin around inside. So the problem is how are you going to do something where you can transmit into the earth and not deal with the circulatory effect? So this is where Tesla's researches and writings and work are most important, is how did he accomplish this? And the implication out of this is the existence of another space called counter space. Shortly after these things started being developed, a guy by the name of Rudolf Steiner started to come up with a way that the mathematics, him and his followers, would get into this what he called a counter-spatial situation. In other words, now there's not just one space, but there's 2 spaces. And it's very similar to this addition and subtraction situation. Now, the thing that makes electricity so interesting and worth studying is the fact that electricity, in always being a 4-pole situation, exists in never any less than 2 dimensions at one time. There is no electricity unless you have magnetism and you have dielectricity. Otherwise, it's just magnetism and dielectricity. Until the 2 are united in some type of geometric configuration, you do not have electricity. So what Tesla had done was, with electricity now, mathematically, electricity gives us a situation where we have to have plus 1. In other words, we have to have 1 multiplied by positive 1, where we have negative 1 multiplied by positive 1. So it gives us our positives and negatives. But now in another situation, we got this counter space situation. Now we have to figure out how to express that. Well, now we got 1 to the plus 1 power, and we have its conjugate plus 1 to the minus 1 power. So now we have taken a step from addition and subtraction to now we have multiplication and division, which is a more compounded, abstract type of process. And it's always in a logarithmic form. It's not in a linear form. It's not additive. It's compounding, cumulative in a certain sense. It's a situation like 1, 2, 4, 8, 16, 32. It's that type of situation. So what electricity implies, if this is our spatial, because multiplying is usually your spatial deal, where addition subtraction is your time deal, is in electricity, unlike in physical situations or physics situations or anything where you're dealing with regular matter, is now you have electricity that goes forwards in time and you have electricity that goes backwards in time. You have electricity that exists in space and you have electricity that exists in counter space. So any electrical situation has to have these poles or polarities in order to be electricity. Otherwise, it's just one end or the other. Now, to get a little more into the erasure process here again. Get into kind of how this electricity behaves. So I'm trying to make, a step at a time, I'm trying to make it less abstract. Yeah. This is a good time for questions. I can hear Yeah.
Well, I always think in terms of nonlinear space-time. So how does your, I mean, because I find this really intriguing. So if one assumes that space-time continuum is nonlinear, evidence kind of shows us a little bit, then would that also affect the behavior of this bidirectional electrical activity that goes forwards and backwards in space and space and counter space? I mean, how do you see that model fitting into it?
Well, that's what I'm going to get into, how that actually manifests physically using pieces of metal.
Because this kind of suggests that the Philadelphia experiment, not to harp on too much, probably was sort of maybe in a clumsy way, but kind of nibbling at the edge of this concept. That's kind
The
of
Philadelphia experiment, being that naval engineering is kind of part of my work. If somebody pointed a gun at my head and said, "You're going to do this, or we're going to pull the trigger," you figure it out. Okay. The first thing I would do is I would get my hands on the anti-mine cables that run around inside the ships. I had a Navy minesweeper to take apart once. Actually, we were supposed to put the thing together, but as usual, human geekdom destroys all projects. So a beautiful piece of naval engineering went to the scrapyard. But this thing was filled with cables, that the purpose of the cables was to make the ship magnetically invisible. Okay?
I sort of see your comment.
Yes.
But I'm just saying that since very recent evidence has not proven these from gravity waves and that space-time is
Oh, but you have to go.
and that space-time can truly be shown to be nonlinear, then it kind of gives credence to this idea that you would have space, counter space, and sort of time, anti-time.
Right. Well, see, the thing is, I don't, in this period of time and mentalities and all that, not really thinking so much of time, space, because I haven't really combined them together yet.
Okay.
Because then I have to use a differential equation where not only am I varying with respect to time, but I'm varying with respect to space. So I might try to push that far, but right now I'm just kind of,
Let's start with groundwork.
Yeah, okay, yeah.
Yeah, I wanted to ask about the ether, whatever you want to call it. But right now, the ether is is equal to, it's related to the permeability and the permittivity of free space, which is equal to 377 ohms. Is this thing true for all scales of size? I mean, somehow, if things are really small, would it be not 377
No,
ohms?
you're stuck with it.
I mean, are you claiming that it's 377 ohms?
Always 377 ohms.
Regardless of scale?
Right? It's
And,
always 377 ohms if the speed of light is always 2.998
Yeah,
centimeters per second.
There's a thing that refutes this.
But if the speed of light changes, the ohms change.
Yeah. Now, there's
Now,
a thing about,
in a simple transmission structure, that is no longer the case.
But that's on a macroscopic scale. Now, for example, lenses, glass lenses, which you're all familiar with, focus light. But if you put an X-rays through it, it doesn't focus X-rays. You can move the lens back and forth. It's just sort of darker in the middle and lighter on the edges, but it doesn't focus X-rays. There's something happening because the X-rays are even smaller or doing something
Well,
different.
according to Tesla, Tesla insisted the X-rays were not transverse vibrations, so they couldn't be
Yeah,
influenced.
but they're all electromagnetic radiation.
No, they're not. Tesla said that X-rays are not electromagnetic radiation. And there's a big controversy over that. And two whole systems of X-rays developed, the Tesla system and the General Electric system developed, where Tesla could stand in front of his X-ray tubes and not be killed, where if you stood in front of an equivalent X-ray tube of the GE design,
Well, what is
you
the
went
difference
to the
between-
grave.
Well, what is the difference between the Tesla X-ray tube?
Well, that's kind of
and
right now out of the scope of the conversation.
Yeah, but
And
there's
nobody really
qualify
said.
it, because X-rays
Well-
are done by slowing down electrons or slowing down.
Oh, well,
and
we'll get
putting
into. We'll get
Bremsstrahlung.
in. I'm going to try to get into the electron. That's
Yeah.
Tesla. I'm trying to get to Tesla's last discovery, but there's so much. I got to kind of stay on a certain path.
Yeah, okay. This
I
next
can't
question,
just give a 8-year college course in a matter of an
Yeah,
hour.
but this next question is much more simpler. It relates to the Tesla thing. We have a device, which I don't know if you've ever heard of a thing called a toroid,
Yeah.
which is I often refer to it as a Buddhist, kind of like a Buddha belly with a very large content kind of thing. Because in a toroid, unlike a solenoid has magnetic field that goes outside of itself.
Right.
Whereas a
Open circuit. Toroid's
is a
closed
completely
circuit.
satisfied and very content kind of device,
Right.
which has all the wires go around completely around in a circle and nothing sticks out
Right.
of it.
It's the natural form of magnetism.
Yeah, well, now this the thing about it is you take a magnet, you say you have a large toroid, and it's energized by 60 cycle 120 volt, you know, it's like half of a variac or something.
Mm-hmm.
If you put a magnet in or around the thing, the magnet does not vibrate because there's no magnetic
There's no external
field is
magnetic
completely
field, right.
contained within the body of
Right.
the toroid core. Now, what is going on when you take a wire and you run it through the middle of the thing, which has got no magnetic field, and around the outside, a heavy gauge copper wire, and you short the wire, you're forming a loop that goes through the middle of the toroid and around the outside, and the wire gets hot, and the Buddha belly, the Buddha gets angry because now it expresses anger into the wire. But it's not, the wire's not immersed in a magnetic field. It's because the magnetic field is only going to the core.
Well, the magnetic field associated with the wire has to expand out into the core. In other words, the lines of force of magnetism around the wire are concentric circles, and the core has got so much permeability that the circles just stay in the core. But there's a thing about magnetism, so you're bringing out, is that the physical relations of magnetism as we use them don't add up.
Yeah.
And you just pointed that out.
Yeah,
They don't, the toroidal core, it doesn't add up.
No.
There's some way and that's where this counter space comes in. There's some way that the wire, see what you're describing, what you've done is you've made one turn around the toroid that's now shorted out.
Yeah.
Okay, when you do that, the magnetism, that's what I'm going to get into, magnetism can't get out of the short, it's trapped. In other words, if I have perfect wires, okay, and I got current flow and I jam those wires together, the magnetism that's stuck in between those wires can't get out because there's no resistance. There's no counter space to eat up the magnetism. It's stuck. That's the classic zero, what do they call it? The absolute zero thing, where you take the lead disc, okay, and you drop it through the liquid helium and let it get cold. And when it gets down to absolute zero, because the intermolecular stuff can't interact with the electricity anymore, it will float on the magnetism because the magnetism can't get through it. But the thing is the magnetism is not going through the wire like it's spreading out into space. What the magnetism is going into the wire, into an inner space, a counter space. See, that's what I'm trying to get into. In order to understand electricity, you have to have an understanding of counter space, or it's impossible. And you have to be able to deal with a situation where things are coming from the future into the past, as well as going from the past into the future, because the electric wave you're working on is the point at which all these things cross in space and time.
One more theoretical question.
Yeah.
I think this is really fascinating. And the recent experiments with Bose-Einstein condensates, where they can get light to slow down almost to like a few inches per minute. What do you suppose would happen to your space, counter space, time, sort of anti-time realm? I mean, do you have any thoughts about that? I'm just kind of curious. About this kind of
Well, what I want to see is what would be if the product of the two was a certain velocity, then what impedance is the ratio of the two? How does that change?
But I mean, this would be like an area of experimentation. I would think would be sort of interesting, like another handle to sort of open this box up with.
Well, I mean, basically, if you add more inductance coils along the path and you add more capacitors across the path, you can build a transmission line and make a wave propagate at any velocity you want, or make the velocity even go away. That's. But let me get into. I want to get into kind of because nobody knows what I'm talking about right now. Okay, other than the history stuff. Okay, I'm sure there's a few people around, but I mean, it's, what is magnetism? You know what I mean? What's a volt? What's an amp? What are we talking about? Velocity. What are all these things? Okay, so that's what we need to do. That's what I gave you the history. Okay, the reason for getting into these guys, okay, is Tesla found out a way to get out of space and connect to another dimension. And Alexanderson figured out a way to circumvent space completely, or his work implies that you can circumvent space completely and make things appear in one other part of the universe without anything time delay in between. Now, if I want to talk to Alpha Centauri, I sure in the hell am not going to use waves that propagate at the velocity of light, because that would be stupid. Okay, now in order to use Tesla's waves, I would have to have an electrical permeable medium of such capacity that it could handle the flux density to carry the power from one end to the other, and that wouldn't be a likely situation between here and Alpha Centauri. So the only thing I could do was build electrical devices that responded in a scalar manner with regard to space. That way I could communicate with distant ends of the universe without having to wait for the signal to get there.
And this is where the Alexanderson models.
Yeah, and the Integratron.
Okay.
The Alexanderson model, because you went through this and me down there, the Alexanderson antenna is an analog computer of that situation. Now what I'm finding is, which is striking with these analog computers, is not only can I get the waveform or the mathematical function, but I also get the physical effects without the Tesla coil, without the Alexanderson antenna. That is what I would have never expected. And that's what's fascinating, because you might not even have to build all this stuff. All you need is a box full of coil capacitors.
I would love to see this in a cryogenics lab, actually, but that's a separate topic.
So at any rate, so what we're talking about is electricity. Let me change colors here. Maybe this one will erase easier. I'm going to draw lighter. Okay, so let's come up with a dynamical situation that everybody can relate to, because they all drive. Everybody here drives an automobile, or has been in one. So what we're going to do is we're going to use that as our model. Okay, and we're going to analyze it dynamically, just as we would all these electrical things I'm talking about. Okay, so now what we decide to do, okay, is if we're moving at a speed, okay, and then all of a sudden we decide we're going to go to another speed. Okay, and then stop. Now all kinds of things happen when we do this. During this interval of time here, things happen that are measurable. Okay, now if the speed increases at a constant rate, what we get is we have a force pushing us, okay, which all of a sudden becomes a constant force, okay, pushing back. And then when the speed change is over and we're at a steady speed, this force disappears, and then there's no more perception of movement. Now another thing happens. If we measure the quantity of gasoline in the gas tank, okay, and there's 100 cubic centimeters before we start, and there's 50 cubic centimeters after we execute this function, then not only do we have this wave in time, but now we have this little cube in space of gasoline that doesn't exist anymore. In other words, we have this force that appeared and disappeared, and we have 50 cubic centimeters of gasoline that went somewhere and is gone. Now this is what's called differentiation and integration. This is calculus. Okay, this is how Newton and Leibniz and these people, they wanted to find the relationships between these situations of why you have this integrated situation where you have the accumulation. In other words, the gasoline just doesn't disappear at once, but it accumulates or deaccumulates. In other words, it's an averaging process that weighs something that you can hold on to. Now we have this time differential here, which is kind of abstract. It's like only there when we're changing velocity, and then it's gone. So now if we take the weight of your body, okay, and we symbolize it by the Greek letter phi, okay, now we take this, you put a scale against your back in the seat, and we take that, okay, and we symbolize that by the Roman letter E. Okay, and we take this interval of time here, and we call that T. So this is the weight of your body. Okay, this is how much perpendicular weight there is pushing back on the seat. In other words, the reactionary weight, and this is the time in which this happens. Well, lo and behold, then we have a situation where we've analyzed algebraically what's going on with a very simple mathematical ratio. In other words, your weight as a ratio to the time involved in changing your velocity gives you a force E. Now, what I can do without any changes at all is this Greek letter phi represents a quantity of magnetism. Okay, the time t represents the change in that quantity of magnetism, whether I'm turning the current up or I'm turning the current down or the magnet's moving or whatever. And that gives me what's called the electromotive force E. So now everybody here understands Faraday's law. It's that simple. So this is how electrodynamics and electromagnetism were created, was out of this simple relationship. If I have a quantity of magnetism and I vary it with respect to time, it gives me something appears, an electromotive force. Now this electromotive force then can be taken and applied to another situation, and then we can start to compound this stuff out. Now, it turns out there's a pair of these equations in electricity because electricity is working in 2 dimensions. So we already know about magnetism. We know also electricity has to consist of what's called the dielectric or electrostatic field. So now we have 2 quantities. We not just have the weight quantity and the single process, but we have a pair of these things. Now, if I take and use the Greek letter psi to represent the electrostatic field, and I vary that with respect to time, and give the rate change the letter I, now not only do we have the electromotive force, but we have the current. So if I take a quantity of electricity, which I'll represent by the lower letter phi, it consists of 2 parts. Or it can't be electricity unless both parts are present. There's got to be a magnetic field, and there's got to be a dielectric field. And these are the 2 components. The magnetic field exists in electromagnetism in the dimension of space. In electromagnetism, the dielectric field exists in the dimension of counter space. So the electricity is always in one of these 2 dimensions. Okay, now if I take this quantity, the lowercase phi, then that becomes a symbolic representation of electricity. In other words, that is the ether in its electrified state. And it has dimensions. Because everything we're dealing with, there's dimensions. We have the dimensions of time. We have the dimensions of magnetism. These are what are called dimensions. So it turns out to be the dimensions of this are defined by something called Planck's constant. In other words, this quantity can only exist in integral multiples, which gives further justification to the lines of force theory, because the lines of force have definite size in some dimension. So the electricity can only exist in steps of these dimensions because electricity is made out of lines of force. So I can't have 1 and 4256 units of electrical induction because it's got to be some kind of, how would you say, like a whole number. It's got to be in these steps, the whole number being Planck's constant. If we make that, a constant or a number, or just make it 1 in our equation. That's what Steinmetz did in order to make his 24-page equations into a little 1-line algebraic relationship. All as Steinmetz did is instead of giving the waves in a velocity, he gave light seconds. And once he used light seconds in the equations, instead of the normal lengths and times, but used that quantity, everything dropped to dropped to 1. Once that was unit value, then all these the space-time continuum equations you were talking about, then all reduced to either the dimensions of space or time, and you didn't have to be stuck in both dimensions to do your calculations. And that was the only way that Steinmetz could represent these waves that were bouncing up and down the transmission lines, that there just didn't seem to be there's no way you could measure them or calculate them. It's like they were in another dimension. They were all trapped in these time dimensions and space dimensions, and it made them appear not to be there. So these 2 quantities we can derive. We break this down, electricity, into its 2 parts. Okay, now in electromagnetism, these 2 things have they have what's called a conjugate relationship, in that one is the denial of the other. And that's how one can be calculated from the other, and this is what gives us the Maxwell velocity of light situation. So if we take this electrical field, let's start to see what the electrical field looks like. We're going to start with electromagnetism because that's the one that everybody knows about, and that's what we're using, so there'll be no argument or mystery. Okay, what I have is I go out in the street and I look down there, and I see these 2 black wires up on the poles. Okay, the old 1800 municipal railway DC wires still run down this street that's Fulton here. Okay, so we're gonna see what's going on with these wires. Okay, there's 600 volts in these wires at 2,500 amps. Okay, which is kind of cranking. Those buses draw a lot of juice. So we're going to do, these wires, they sit on these pieces of wood, which are referred to as insulators.
I'm sorry, how many volts at 25?
600.
Wow.
The feeders are 5,000 amps out of the rectifier. By the time they get here, it's probably more like 500. But if you look at the insulation all burned off, you can see that these things have been jammed up to about 2,500 amps. Okay, so what I have is I got a place that produces the electricity. Okay, I don't know where the rectifier stations are anymore. There's one back here down somewhere between Fulton and Geary, where the juice comes from. Okay, it's going down the road in between these poles to the buses, okay, that are down at the end of the street coming up here. And it produces all these kind of effects. Okay, what it is the wires are trapping the electricity so it can only go this way, only go down, up and down the line. Okay, it can't go over here or there or whatever. It's got to go one way. There is no electricity flowing in the wires whatsoever to speak of. It's non-existent. It's in the space between the wires. So now if we take these two conductors and we take a nice sideways chop so we don't have to look at the length, okay, we find that around these pieces of wire are circulations of ether. Okay, and one circulation is in one direction and one is in the other direction because we have a basically plus and minus type of transmission situation. This is called magnetism. Okay, and it's there. Everybody's held magnets and pushed them together and has felt this thing that's in between the magnets. The like poles is the best because you can feel like a jelly as you try to push them together. There's definitely something there, and it doesn't fall to the floor when you take the magnets away. So there's no mass. So what this does is it creates a concentration of magnetism in the space between the wires that predominantly moves vertically, okay, at right angles to the power flow. Now this magnetism physically pushes the wires apart. So in other words, when all the buses are running, the wires are going to be a little farther apart on the spans between the poles than they are when all the buses are stopped. So there's definitely some kind of pressure or something exists in between here. Okay, now the thing is the further I spread out, let's take one span as our differential element of these wires. Let's say about 150 feet from pole to pole. I take that section of cable and that's all I'm going to look at. Okay, there's a quantity of this magnetism in between these cables, okay, by this circulatory ether condition, pushing the cables apart. Now if I let the cables move apart, or I spread them apart more by putting in another insulator, moving all the cables over, now this will hold more magnetism, obviously. Now if I put a chunk of iron or some kind of magnetic material in between those wires, okay, that magnetic material is going to suck in the magnetism, and again there will be more magnetic storage capability inside this electromagnetic structure. But with the iron, if I keep increasing the current situation of the magnetism so that the iron can't hold anymore, the iron goes into what's called saturation, and it will no longer hold any more magnetism, and all the rest of the magnetism that's produced by the generating station will have to continue to exist outside the iron. It's what's called a saturation condition. All these things are completely archetypal of space. You can only jam so much in the bottle. Okay, you can only fit so many cars in the parking lot. These are all normal properties of space. Okay, now we'll look at these wires a little further. Okay, well, not only are we dealing with the current of 2,500 amps, but we're dealing with a voltage of 600 volts. Because we've got to have the volts and the amps. We've got to have the magnetic and the dielectric before we have electricity. Okay, now these lines of force, if I take one wire and focus in on it real close, okay, the magnetism goes around like this in perfect circles if the wire's a perfect circle. The dielectric is completely contrary. It's conjugate. Everywhere in space, a magnetic sectional line of force has direction. The dielectric field will always be at 90 degrees of that, and there's no alternation of it possible. Okay. So we have where the magnetism is concentric, the dielectric is radial. And this, if one is one way, the other is the other way situation. This conjugate situation always exists everywhere in space. So if you know where the magnetic field is, you know where the dielectric field is. Okay, now the dielectric field, where magnetism has to form closed loops of a circulatory type of fashion, the dielectric field is radial lines that contact the metal surfaces. So they come out and they arch. And everywhere in space, they're at right angles to whatever magnetism exists. So now we have another field of force that exists as a conjugate to the magnetic field of force. And the two of them make up the electric field. Okay, now these forces, the more I raise the voltage, the more it wants to pull the wires together. Not push them apart, but pull them together. So the force is opposite. Now, if I move the wires closer together, these electrostatic lines of force or dielectric lines of force become even more concentrated. So now that I've moved this section of transmission line, the wires close together, the closer the wires are together, the more electrostatic energy the system will store. And it tends to pull itself together, where in the magnetic, the more magnetism there is, the more it wants to push the wires apart and make itself bigger to store the energy. So now we're starting to get into the concept of counter space. We've entered the counter space logic right now. We have two spatial conditions. Okay, now if I take and put a piece of glass in between these wires, like I did the iron bar for the magnetism, the glass will absorb up more dielectric lines of force, and the energy storage will be greater. Now, if I keep turning up the voltage to the point where the glass starts to saturate and can't handle anymore, what happens is, instead of pushing the lines of force out, what the glass will do is start to draw even more lines of force in until the point at which it blasts. That's when you get sparks across power lines, lightning discharges, that type of situation. That's what's going on. Now let's take a lightning discharge as another flux example. Okay, we got the clouds, we got the Earth. Okay, now because we know about these lines of force, we know that there's this volume of space, of ground and thundercloud, that is filled with a quantity of electrostatic lines of force. Okay, which are basically trying to pull the cloud and the Earth together. Okay, now what happens is the cloud evaporates the water, which is holding 50 times at least the amount of lines of force that air can hold, is releasing this electricity and it has nowhere to go. So what happens is these lines of force start to become tighter and tighter. And what it'll do is it'll start a saturation in some spot of air, just like in this piece of glass. When I kept turning the voltage up, it'll start to spark inside and then it'll blast. And so the atoms start to break apart at the point of saturation, and you get a breakdown zone. And what happens is when that saturates in a counterspatial, yes, there's something you want?
Step maybe a bit away from that board for the camera.
Oh, okay.
Thank you.
Yeah. Once the saturation process starts, all the lines of force will come running into that and discharge the complete 1 cubic volume of electrostatic lines of force in one fire column. Saturation is complete and total. There's nothing jumping from the cloud to ground or any of these types of, those are all myths. If you build your lightning protection system on that, you're more than sure to get blasted.
What did you say it was doing?
It's a saturation. It's moving in sideways. It's like if I have a bottle full of water, and the water represents the electrostatic field, okay, and then all of a sudden the water or something starts to break down, like in the middle, and the more water rushes in to make what was gone. It's like the whole jar of water collapses upon itself into nothing. And the energy density is so high at that point that the fire appears. And that's why there's the blast. So lightning is not moving vertically, it's a saturation collapse coming in horizontally, and it produces this what's called impulse current.
It's all the static meant into one line.
Yeah, it's a saturation into counter space. Okay, now when I'm sending the electricity down this line, what's going on, okay, is everywhere one of these lines of electrostatic force and one of these lines of magnetic force cross, there's a co-joining. You have a process of multiplication. It's basically the symbol of multiplication, the cross, which takes us back to that polarity thing. Again, it's always the four-pointed cross. It's an Indian archetype, actually. At that conjunction point, in space and counter space, is produced the electromagnetism which moves down the line, and this is what's represented by Planck's constant. This is the product of the electrostatic and the magnetic lines of force, and this is what exists in quantum steps. And this is what propagates at the velocity of light. What rate the magnetic lines of force and the dielectric lines of force move has never been determined. Okay, the equations exist in Steinmetz's book to make the determination, but nobody ever followed through to do the experiments. But they necessarily have to be doing something because the energy is moving. So the movement of the lines of force and the energy, what they do is they're scraping into the wire because the wire is not a perfect conductor, so to speak. But the wire is not conducting this. The space is conducting this. The wire is a reflector. That is basically why all electromagnetic boundaries use a material which reflects light for the so-called conductors, and it always uses a material that absorbs light for the so-called insulators. All electromagnetic boundaries must be capable of reflection, or they will not work. That's the basic engineering principle. I'm sure there's some modern plastics that'll do something, but this is the basic process that's going on. So we have electricity trapped between two mirrors. But the electricity is of such a dimensional nature that it doesn't have to be complete. It doesn't have to be big mirrors. It's just the presence of the cables is enough that nothing can get through them. Okay? Now, the thing is the electrostatic lines of force tend to embed themselves in because they have to make contact with what are called electrons and protons, which are the ends of the electrostatic lines of force. In themselves, the electrons and protons have no material physical existence. They're terminals of this type of electrostatic condition, and this is where the theory of relativity collapses, is in this particular aspect of what's going on with the electricity. So being that all this is in a speed of light commotion, traveling down the lines, it's dragging through the wire. And then the wire basically burns up the electricity, and there's a sympathetic current flow in the wire that cannot move anywhere near the velocity of light down the line. And it's a situation quite analogous where if you're going down the road in your car and you've got to slam on the brakes, what happens is as you skid down the road, it makes a sound, okay, which is called enharmonic. It's a distortion type of sound where energy is being destroyed or consumed. And part of the road will be carried along with the car, but not at the same rate as the car. The pieces you rip up will always fall behind, and the skid marks will always be left behind, but there will always be the tendency to move. And this is why the wires get hot and give the indication of current flow, but the current flow is the rate at which the electricity is destroyed. So now what we can do is we can give these quantities symbols so that we can work with them. So we have now, we've talked about the magnetic field. Okay, we've seen what it does. We can feel it. We know why it makes things get hot. We know what it does when we try to confine it or put it in a container. We've got that down. Same thing with the electrostatic. So we'll call the magnetism L, and we'll call the dielectric C. Now the way we derive these is if I take a quantity of magnetism, which we worked with in an analogy, okay, and I take associated current flow that goes with it, that it drags along the wires, it gives me this quantity L, which is called the magnetic energy storage coefficient. This is one of the most important quantities in electrical engineering. There's 4 of these. This is what I'm going to try to develop. L is the ability of this geometry to store magnetism. If I pack that space with iron, L is going to go up because I'll have more magnetism per the amount of current that I can detect by its movement against the wires. So basically, the geometry of the wires determines this energy storage coefficient. Now, with capacitance, it's the exact same situation. Because you have the dielectric flux, okay, and you have the electromotive force or the magnetism that's associated with it that gives rise to it, okay, and that gives us C, the capacitance of the system. So we have electricity is represented by the quantity LC. So now we recognize that from the Heaviside equation. This is back to that LC, whatever. I'll try to get back into that. So, but now we also have the magnetic field is dragging into the wires and causing them to get hot. So what we have now is we have an energy dissipation coefficient. Okay, and we'll call that R for resistance. And then the electrostatic lines of force have to terminate in the molecules, and that's agitating the situation and getting hot. So what we're going to call that is G, the conductance. So we have LC and RG. So basically, the heating of the dielectric field occurs mostly in the insulation and the insulators of the wire, and the heating from the magnetic field mostly occurs in the metal pins and the copper and all that of the electrical transmission system. The metal pins will get hot even though they are not in the so-called electronic-minded current-carrying path. Is if there's any cycling or carrying on with the electricity, switching it on and off, the iron will get hot as well as the copper. So for alternating current, everything gets hot.
Were you suggesting a moment ago that electrons and protons have no rest mass?
Exactly.
Really? Okay.
They don't have mass at all.
Interesting point. All right.
I'll try to get into that, but then I got to bring up J.J. Thomson. And then we get in, not only do we have two fantastic stories to believe, but then we'll have three.
That's a pretty interesting claim. I'm happy to hear your elaboration on that.
So basically what I've done is now, when you look up at the power lines, okay, it's not just some metal there. Now everybody here can kind of get an idea that there's a dynamic, just like the thing with the car. When you speed up, there's a dynamic that occurs. Things move, things change, things readjust. And this is our basis for electrical engineering. And it's not complicated. It's actually a very simple type of thing, as long as we have all these ideas, in our mind that were developed by Faraday and the people that discovered electricity. Okay, now what the Einsteiners tried to do was basically say that there is no electric field. It doesn't exist. All you have is the crossing point, which they call photon. And none of this other stuff even exists. It's just simply not there. Now, you just brought up the topic, so I'm going to get into that. Okay, the thing is the theory of relativity emerged from the writings of a guy by the name of J.J. Thomson and a few others. J.J. Thomson's the most important. J.J. Thomson revitalized the Faraday theory when the rest of the world was going back into the Newtonian action at a distance. To him, the lines of force were real, they were solid, they were there. I did an experiment when I was a kid. It's very simple, determined the same thing. I got a nice set of very sensitive, sound-powered Navy headphones from the Air Force Base. I had a magnetron magnet from one of their radars, and I had a 440-volt relay coil. Lots of turns of wire. Put on the headphones, connected to the coil, and waved it around the magnet, and I could hear the individual lines of force scratching through the windings. There was a fibrous something there. The faster I moved the wire through the air, the higher pitched the scraping noise was. So there was something scraping or acting, and to me that is another experiment to establish the physical reality of the lines of force. Okay, now the Einstein and the physics and all that, see, we're kind of back in the same situation now we were with Oliver Heaviside. The physicists said it was a diffusion problem and based all their work on that, where Heaviside said it was an electromagnetic, a double energy type of situation that had to be balanced. So again and again, these things repeated. So J.J. Thomson discovered a phenomenon called the electron. He is the one that gave us the concept of the electron. And here's how the concept of electron worked in J.J. Thomson's mind. Is in one of these electrostatic saturation conditions, let me take the inside of a radio tube. or some type of deal where I've got two metal plates in a vacuum with 100,000 volts between them, so I have this nice intense dielectric field. Okay, it's straining everything. The plates are being pulled together. Okay, what it starts to do is if I keep cranking up the voltage, it starts to pull what it's connected to in the atom out. The atom can't hold it anymore. It's starting to yank out. So what happens is one will break. One line of force will break loose, and you will have what's called an electron at that end of line of force, because a line of force can't just break and end in space, according to the Faraday theory. So this end of line of force, now you have a rubber band of dielectricity that's snapping, okay? And its energy is being discharged in this snapping to the other plate, the positive plate, and that produces a physical action and a heat. Of course, now the Einsteiners said there are no lines of force, so all we have is the electron, which is a ball bearing that floats in empty space. And if we drop it to the floor, then we'll have electrons rolling all over the floor. But somehow that just doesn't work out like that. It doesn't seem to have any real mass. The mass is all related to the rate at which the electric field is moving. It has nothing to do with a physical object. Now, what was found was, just a second, what was found is that this electron phenomenon, if you try to make it happen faster, you cannot, if you have all the energy in the world, you can make it happen at the velocity of light. And anything less than that, it cannot reach that speed. And this is the basis for the proof of theory of relativity. The electron is not a ball bearing. Nobody knows. The only person that knew what an electron was Philo Farnsworth, and he wrote no books, and he's dead. Yes?
Well, the thing is, you mentioned about the cathode and all that. Now, if you have no voltage across the anode and the cathode, and you have the heater, you know, because a cathode is a thermionic thing with.
No, this is a cold cathode.
A cold. Well, the cold cathode is a different thing. There's two phenomena that makes a cold cathode work. One is it depends on ions. Ions hit the surface of the cathode, and then electrons come off. And that's what they like.
Well, that's after the breakdown. But you got to turn up the voltage to the point where the charged carriers get pulled out of the metal.
Yeah, well, they call that brute force field emission, which is where.
Thermionic emission is where you heat this plate up to red heat, so the electrons can't hold on very good anymore.
Yeah.
And you can just heat it up to the point where the electrons just kind of boil around the whole thing, but they got nowhere to go because their lines of force are all going inside. They're not outside.
But it also results in the cooling of the cathode. The cathode is actually.
It's actually, on a field emission, Tesla showed that when the anode gets hot, the cathode refrigerates.
Yeah.
Which is kind of a remarkable thing in itself. So what led out of J.J. Thomson's idea was, when you read his book, which is very simple, his mathematics is kind of shoddy, but there isn't a lot of it, is that here's the implication of J.J. Thomson's work. Okay, is space is filled with electricity. We don't know what the voltage of the planet is with respect to the sun. You know, we can't just say right off the top of our heads what the magnetic field intensity is in this. But at any rate, if I got my car sitting out in the street, it's being that it's metal, it's got all this electrical lines of force attached to it and surrounding it. Okay, now according to J.J. Thomson, that is the reason why when I slam on the brakes, the car doesn't come to an instantaneous stop. It's because the electricity has to discharge. So J.J. Thomson's idea was, if you took and found a way to make the voltage and the current associated with the metallic body of the car equal potential of where you stood in that place in the universe, so all the lines of force detached, because there's no difference of polarity, that you could step on the brakes and the car would come to an instantaneous halt. And basically, velocities and all of those things would almost lose their meaning because there would be no restriction to the movement. Now the problem is, okay, well that sounds good. How do we begin? Well, the Einsteiners tell us there is no universal ground or neutral wire or point of rest or any of that type of stuff. So we'll have to give up at that point. But at any rate, somebody pointed a gun at our head and said, no, you're not going to give up. You're going to figure it out. So what we'll do is, well, gee, Tesla came up with this unipolar idea where he could ground in the counter space. Well, what would lead out of that is the Tesla device could be phased or tuned in such a way that its counterspatial neutral would be at a universal grounding point. And grounded against that, then your vehicle would have no potential because it would be grounded to this dimension, and all the electrical lines of force would disappear. Now, there's a lot of people believe that the Germans developed that in aircraft, and the United States glommed onto all of them during World War II, and they did indeed disappear into Bell Telephone and some weird place in New Mexico I can't pronounce the name of. Who knows the name of that? Algamorado or? Okay, yeah. So the contention is that all this talk of aliens and UFOs and all that is just a weird type of compounding disinformation story where they actually throw the material out and then deny that it exists, so the whole thing just becomes a self-consuming lie, and nobody realizes it's really actually Earthlings doing this stuff. But of course, that's all, Art Bell world, so I won't get too hard into it. But these are all the things that pop up when you get into this electrical world. And it's my conclusion that that's the main reason why all electrical research has been stopped and swept up, is because the possibilities are incredible. Absolutely incredible. So, some more questions.
Well, speaking of Art Bell, because he had his parallel line loop antenna, do you think because of that particular configuration, and he had this other space between those two lines, that's why he's putting all that voltage on?
No, the reason he's getting all the voltage is because it's a great story. Art Bell is an entertainer. You've seen the same piece of loop of wire, you've virtually touched it at my place, and that's just not happening.
But they did have this very long, exactly parallel matched loop. I thought maybe that configuration matched your model for the dielectric field in between.
No, Art Bell is an entertainer like
Okay.
Michael Savage.
And my last question would be, just to make sure I got this, because I'm still trying to figure this out. You're suggesting that protons, electrons have no rest mass, but that their apparent mass is a function of the velocity of the force lines. Is that correct?
Right.
Okay, it's a theory. I'm digesting it, but it's interesting.
Yeah.
Before you ask the question, could you elaborate on your last statement about the information about electricity is being gathered up or whatever?
Well, if you look at electrical history, okay, you can see it was just a ball of confusion for 300 or 400 years in Europe, where such things were observed. Obviously, the Hawaiians and the Aborigines weren't doing much experimentation. It all came out of that neighborhood, and then it just boom, it took off. Twice it became, with Franklin, it became almost like a fad that everybody in France was wearing lightning rods on their hat. I mean, every phase of electrical advancement resulted in this social reaction of complete amazement and partying, like when the telegraph line was finally sent across the ocean and all that. It was massive effects. There were riots on the street when Einstein and Darwin presented their theories to the public. See, all these things have disappeared from the history books. So you go through and you see, if you read, what I did is I read all the minutes of the American Institute of Electrical Engineers from its inception to the death of Steinmetz. Page at a time. I went through everything, looking for, qualms, so to speak. Little goodies, things that I could, get something out of. There was one meeting where all these guys were together. And they felt that within a matter of months, with Steinmetz's work and Tesla's work and all the stuff that was being discovered by Heaviside and all these other people, it was a matter of months before a rotating apparatus was going to be built that provided electricity without requiring a prime mover. It's right there in writing by the chairman of the meeting, Professor William Anthony.
And what happened? Why?
It just basically step by step, because of the physicists and the Einstein and all that, just got chopped and chopped and chopped until eventually electricity has been declared impossible to even exist. Every device that hangs on those telephone poles now, every electrical device you have cranking or whatever's going on in your car, any electrical device that's pulling the elevators up and down, running the blowers, powering these light bulbs or any of that stuff at all. It was all invented by Edison and Tesla and a few other guys.
Who was
And,
doing the shopping?
well, I don't know, figure it out.
Well,
All I can do is speak from experience, okay? Everything I've built has been destroyed.
right.
Let me finish. Okay, I'm just going to speak from my experience, okay? Everything I built has been destroyed, okay, as people have been hounding me and harassing me my whole life, ever since I was 6 years old, even before I came up with anything. It took a while to figure out why all this worked, okay? And I won't get into it. But I'll get into the specific example, okay? As the thing is when I was a child, okay, I wasn't interested in riding bicycles or kites. I didn't need to go goo goo gaga, see Dick run, see Jane run in the classroom because I was too busy reading my father's naval and electronic engineering books. That's how I learned to read. I just sat down to open the books and read them. I don't know where I learned how or whatever, but that's immaterial. That's just what I did. I probably got enough out of the kindergarten class or something. Okay, when I was 12 years old, Pacific Gas and Electric took me on in a private tutoring special education situation. Okay, and then the phone company came next. Once I had all my federal licenses when I was in high school, the phone company came in with a couple of spooks that looked like some CIA guys with, you know, the gun in their pants, but not quite. You know, where's Eric Dollard? You know, and it was a couple of stunts that me and my buddies pulled the week before. I was not feeling happy. And they go, we want you to attend this meeting, special meeting. And it just kept going and going like that. And then RCA came in Bolinas. Okay, and when I was 17 years old, I was completely absorbed into the station. I could come in there any time of day or night, get parts I needed for experiments, had the keys to the gate, you know, so we could party on the beach. All these type of things. Okay, RCA, the phone company, 1970, what me and my friends called the day the music died. Okay, all those companies started going down like that. So what I did is I managed to glom on to a couple of corporate engineering executives in these companies, okay, and told them what I had set out to do, electrically researching, and I had the full backing of these big corporations. RCA gave me all of their equipment in Bolinas, except what was actually online. 25 tons of apparatus.
To do what?
For my research. Transformers that stood 7, 8 feet high. There's a few people here that were with me in that episode. Actually, only one person. I don't know where she is right now. But that's it. Nobody, that's all gone. There's no see or belief or anything. An environmental organization came in, seized the whole situation, hired high school vandals to smash all the equipment with hammers and axes, spread the mercury and the PCBs all over the floor, the environmental saviors, smashed everything, cut all the cables, dumpstered all the notebooks, tried to make sure I had no place to live in town.
Yeah, but they were hired by...
No, they own the place now. They just simply took it over and then pushed RCA, what was left of it, to the other side of the wall,
Yeah, but
as
then
we
they
said.
were hired by other people who were hired by other people.
Well, I don't, that's all for other, that's for you to figure out. I'm just leading the trail. You go talk to these people, okay? You go to Bolinas and you go to the RCA station and they call themselves Commonweal. You talk to them and get their story. That's how you deal with those type of people.
Well,
Okay, they managed to get
They were
the,
hired by other people.
so at any rate, let me continue. I don't know who, you know, I'm a scientist and an engineer. Okay, I can't speculate, otherwise I'd just burn my whole life up chasing UFOs and space people and Soviet Tesla scalar conspiracies. You know what I mean. So what it finally evolved to is a guy and a friend of mine got together with me and we went with a videotape camera, okay, and went out into RCA to get pictures of the last of the antenna field and everything before it was finally smashed down. Well, in the process of this, by some weird turn of events that I won't get into because it sounds like voodoo, it finally resulted into the chief park ranger himself, Mr. Sansing, searches the entire 3,000-acre antenna field, which has been my personal rat hole for 30 years, to find the hated Mr. Dollard. And he finally does. He finds us down in the ravine, taking a break, you know, where the deer hang out. Not easy to find. He must have took him at least an hour, you know, worrying about tire pungees and low-hanging wires and the whole thing. And they found me, and he did that so he could come up to me and say, quote, Mr. Dollard, There will be no more electrical research done here ever again. Do you understand, Mr. Dollard? You know what I told him? No. And it didn't stop there. So you figure it out. All I know is it's just, it's that percentage of carbon monoxide in the air that I got to live with.
But what about all the hidden budgets now in the executive branch of the federal government?
I don't know anything about that.
Oh my God. They can take all your research and turn it towards military use.
Well, good. Let them blow up the world.
Well,
They're going to do it anyway. Have you heard about the National Ignition Center? Oh, it was on KNX News in Los Angeles. We had a whole party about it in Bolinas, amongst a couple other issues. What they're going to try to do is set off a nuclear bomb and contain it in the East Bay, in one of their laboratories.
where?
Liverwurst.
Yeah,
I don't know if anybody can confirm that, but if I hear it on KNX, I believe it.
The straight, that's been, they said they're not gonna do this big straight, hit because it put radioactive dust in the air.
Well, whatever. They're crazy.
They're still doing a contained version of it. I mean, that's been.
So here's the basic situation. You got this place. I don't want to insult anybody that's worked there. You have this big installation, Livermore Laboratories, the big government laboratory.
Right.
Big shot government laboratory. And out of the whole fusion era came this holy grail of producing electricity by hydrogen fusion, which didn't throw out all this garbage and crap like fission does. It's more of an implosive, self-contained type of thing. All the billions and billions and billions of dollars, giant magnets and lasers, 220,000 volt power lines on towers, 150 feet high, insulators 20 feet long, big giant flows of money, gas, electricity, and glom pouring into this place, all for one simple engineering premise. They wanted to make a fireball stand in space. Okay? Well, nobody seems to be able to do it. Well, when I was living in the bushes in Bolinas, there was a deranged guy that lived in a house next to the bush. Okay? His name was Philo Taylor Farnsworth III. So I began to get drunk and stoned with this deranged man, okay, and was told that he's really off his rocker, okay, and nobody wanted to even bring me near him, and I didn't know, and I looked at his facial features, and I go, well, he's got to be a Farnsworth. So at any rate, we get drunk together, and the first thing, the drunken mentality, along with all, the foul language and puffing up like frigate birds. My transmitter put out more power than yours. And the whole thing, it results in that I tell him one of my best stories, which happened to do something that created the beginnings of a fusion reaction. What we used to do when I was a kid is the science club was kind of also the pyromania club in those days. Janet Reno wasn't invented yet, okay? So weird things would happen. So in the course of experimenting is I could get all the old tubes from RCA. I had moved a 10 kilowatt transmitter from RCA into my parents' garage. Okay, this thing was the terror of the neighborhood. Well, I found out this terror spread a little farther than that. So what we did is we get these big tubes, back in these giant globes, and of course the ones that were good, were very carefully taken care of. But the ones that were no good, if you still could get current through them, okay, as my parents once a week would go out to a movie or something like that. So a whole science club would show up to my laboratory, okay, and we would play Nuclear Meltdown. And this is what playing Nuclear Meltdown was. We'd take the tube, okay, we'd hook it to the big 3,300 volt switchboard. This thing's got about enough juice to run a whole neighborhood. It's clamped right where the wires come in off the meter, on our side of the meter, but nevertheless it had to be clamped right on. It just draws so much power the whole neighborhood would just go into a brownout every time the telegraph key was hit. So it was a 3 or 4 person operation. One man controlled the plate, one man controlled the screen, one man controlled the control grid, and somebody kind of had to deal me with the whole, to get this thing hotter and hotter and hotter and hotter. Okay, and the thing all of a sudden would go at some point and would take off, and all the meters, the big Frankenstein switchboard, all the meters would go backwards, okay? And the bravest guy had to have his hands on the abort switch to interrupt this, interrupt this sudden explosion of electricity. that would be created in this process. Just briefly, there'd be this sudden explosion of electricity. Well, it turns out the diffusion reactions of this type are very heavy microwave emitters. And I learned when I got in the Navy, every time we did this, it jammed out all the radars in Hamilton Air Force Base. So when I told that to Philo, oh, he was just completely bent out of shape. He couldn't have a better story than that. But he had to. So he disappeared into his bedroom. It was a typical madman, house of boxes, books all dusty, piled to the floor, the ceiling. You couldn't turn the TV off because of the weak cathode, so you put a piece of cardboard in front of it. The inventor of TV's son couldn't fix his own TV. It was a madhouse place, Lots of bottles of wine going down in his guts all the time. Drugs I've never even heard of before. But at any rate, that's where the action. When you live on the street, you're more tolerant. So he goes into his room and he pulls out this screwed up cardboard box, about this big, and he dumps it on the table, and he goes, well, you're so smart. Tell me what these are. And I go, what do you got here? He goes, these are my father's tubes. Okay, well, I knew about the TV, but these weren't TV tubes. Okay, so I pick up the tubes. I've been playing with tubes since I was 6 years old. My grandmother used to build them in RCA. It's just in my genes. I look at these tubes, and these things they're crazy. Anybody would say this is insanity. Okay, big giant grids, but no cathodes, and like electrodes sticking out of the side, and all this stuff. And but the thing is, I know how to make tubes. So I'm looking at him, and I start to see what's going on here. And he's sitting there. Remember that cartoon character of that dog that would laugh with that kind of horse after the dog screwed somebody that screwed him? I forget the character. That's exactly how Philo laughed. It was that kind of... You couldn't really hear it. It was kind of like a growling inside. He was content. So I pulled this one tube out, which was just an empty quart of glass, and it had an umbilical cord, so to speak, that came off of it to pump all the air out during operation. It was a laboratory tube. They broke it off the pump and discarded it after the experiment. Said two little metal shells pointing at each other, kind of like two little mirrors, coated with some kind of crappy-looking stuff, silver cesium oxide compound, and a simple ring in the middle. Well, it's a simple, electrostatic focus tube with an anode in the middle, and the two plates, and the little tiny wires came in because the voltage was so high. I guess it had to be oil or something around. It looked like it operated about 100,000 volts, which is a lot for a small tube. But I look at the glass had been all attacked by something. So it used to be in the old color TVs, there was a certain tube that shorted out the high voltage so that it couldn't get out of control. It's called a shunt regulator, 6BK4. And they glow every color in the rainbow and make the TV repairmen sick. And what it does is it turns the radiation turns the glass on the tube chocolate brown. And that's how you can tell how long the tube's been in the set. So I'm looking at this glass, and it's like all baked by some kind of incredible electrical activity that couldn't have come through those little tiny wires. So I go, Philo, something took off in this tube, didn't it? Then he stopped laughing and got all crappy with me again. I go, Philo, tell me what happened in the tube. And so he told me I could see what happened. What happened is and this is about 1932, is Farnsworth was working with a radically new vacuum tube technology that did not use any of these glowing cathodes or any of these emitters. The patent situation back then was such that RCA owned radio. You couldn't build anything. That's what started in Bolinas with the Alexanderson system. Lit this thing up, a star appeared in the middle, turn off the power, and it stayed there for a brief period of time. So that changed my life forever. So here you have this giant laboratory and all these billions and billions and billions of kilowatt-hour dollars being expended and all the grooviness and frigate bird activity that goes along with it. And here's some guy in a laboratory on Green Street in San Francisco, okay, on a poverty existence because he's never got anything out of television, does the same thing in an empty bottle, for so to speak.
Where are the tubes now?
The Farnsworth family still has them, but it doesn't stop there. So what happened is my first laboratory got destroyed in San Francisco, and that's when I lost most of the RCA equipment. That's all based on the campaign slogan, Diane will make a difference. So that's when San Francisco basically swirled into the outgoing tide. So my 8 cents a square foot went to $1 a square foot. So now how are you going to move tons of switchboards 15 feet high, transformers that weigh 4,000 or 5,000 pounds? Commonweal had already smashed the rest of it at RCA. The Park Service got my warehouse at Fort Mason Pier 3. So everything went to the dump. And it was time to eat out of garbage cans again for another couple of years. So what I did is I made friends with a high school kid up there in Bolinas who was a prodigal genius type thing that Philo had trained at an early age. The kid was a genius beyond belief in a lot of different areas. He started hanging out with me. So we built a laboratory in this bedroom. So what I did is I took some of the remaining pieces from RCA and configured them. I decided, well, there's nothing else to do with this stuff other than make a Tesla coil. But make it the way Tesla decided to make it. At any rate, to make a long story short, we worked with this and experimented, went out to RCA, got more transmitter parts, because I could always go back out and get more, because the station was still operating then. We build this thing. I take old burned out street lights. We're using the experiment. We get dumpster loads of them from Lease Light in San Francisco. The street lights off of Van Ness Street. They pull them out every certain amount of months. And there's a whole dumpster full of them somewhere. There used to be. We put the street light in these monopolar fields that I just described from these coils. And the street light that we used for this experiment was the one we'd used previously for all of our spark gap experiments and everything. And something had started to transform with the bulb. We put this thing in the field within a matter of a minute or two of working the thing in the field. You have to be careful because they explode violently. Full galaxy appears inside the bulb, just like a picture of one of these Nova TV deals. You can spins, whole thing, the stars, the nebulas, the suns, all the colors of the rainbow is spinning inside a burned out street light and virtually powering and containing itself, which has gone beyond the Farnsworth. Now we have a whole astronomical creation floating around in a light bulb on a workbench, and then it explodes the bulb. But after it explodes the bulb, for like 1/10 of a second, it's not long, it sits there without any bulb to contain it.
What is it? What's in it?
That's the creative force. This electrical monopolar field is how creation comes about. There is no evolution or any of that type of stuff. It's the electrical field at the time creates what exists, and it's always changing this way and that way. All living organisms are all based, just like all machines, are all based on the same mathematical function. All trees, plants, flowers, humans, everything's based on what's called the golden ratio. It's a definite geometric pattern, and all of these electrical discharges associated with these Tesla transformers are all golden ratio proportioned and tend to be self-organizing and self-powering. So that ends the story. $1 trillion in the Livermore laboratories, and a deranged high school kid and a homeless person go beyond it in the laboratory. And that's how I was endeared to the Farnsworth family. Because Philo's mother, which was the wife of the inventor, came to the laboratory to see this, and when she saw, that this is going on with junk and no money, and her husband had devoted half of his life to researching this, then it was time to start being friends and talking. So I had their whole Farnsworth notebooks and everything available to me, all of it.
He's referring to Pem Farnsworth, who spoke to us in 2002 at the Tesla Society by phone on the anniversary of the 75th anniversary of television, invention of television here in San Francisco. That's the same person, Pem Farnsworth.
Yeah, your question.
The neutron, does it have mass?
I don't even know if it exists.
Very well,
It doesn't enter into the electrical equation.
the star. You can reproduce the effect that you described, the astronomical emergence. This is reproducible for you?
It's hard, but yeah, it can be done.
It sounds like you did it in a field with some broken stuff.
Well, what I did is I built a radio transmission device based on Tesla's work, and I built a pair of them so it couldn't transmit. It could only focus in one spot. And there's a neutral plane. If you take two monopolar fields and point them at each other, there's this weird neutral plane between them, and it's kind of like an opening into another universe.
What was the
And
frequency of this transmitter?
this one operated, the frequency's immaterial pretty much, but it's got to be an
Why is it-
HF band. It operated at 3.3 megacycles.
All right.
The voltage was about 60,000 volts. The electrode area at each end was about maybe 15, 20 picofarads of capacitance. So basically the tube sat between the plates of a capacitor, so to speak.
Eric, I have pictures of Bolinas we can put up on the screen if you want to talk about that at all.
Okay, well, what's the time frame and which way does everybody want to go? Because I can keep going in any direction.
Further, how about an intermission of a few minutes?
Yeah, that might be good.
Okay.
Yeah.
Thank
And
you.
one more question?
Yeah, I just wanted to make an announcement here. Hal Tracy, who was a member of this group who lives in Nevada and couldn't get here, made a copy and sent me a table of contents for a book he wrote called Wireless Radio, A History of the RCA Bolinas Facility. I have copies of just the table of contents, and I guess we'll just put it up there if anybody wants to see that. And I think he's also trying to put together some other...
Well, I'm putting the whole thing on the internet right now.
You are, okay.
We're,
Yeah.
we're going to put a whole bunch of this.
That's my last book. That's what's sitting up here. What I started was, try to get some simple facts down on the station, and it emerged into like a 3 or 4 year intensive study, which basically resulted in me learning that the Alexanderson system was not what they taught me at RCA or in the books. It was way beyond that. So that became my most recent and present form of research, is the RCA Alexanderson system that was in Bolinas. That's when you were out there?
Yes.
Okay, yeah, well, that's the wreckage of the station, but it's better than nothing.
This is Bolinas.
Did RCA know what they had?
RCA, here's how the whole situation came about. Okay, Marconi robbed Tesla and came up with a completely impedance mismatch system compared to Tesla, but it got around the patents and it kind of worked. He really jammed a lot of juice into it. So he built 5 stations around the world. The pilot station was in New Brunswick, New Jersey, and the first operative steps out of that was Bolinas and then Hawaii, and an attempt to get to Japan. What happened was, being that Marconi was a foreigner, and this war thing was building up, this was around 1913, 1914, the Navy decided that Marconi was going to get the boot. Okay, at that time, General Electric had, through Alexanderson, had finished developing the Alexanderson system. So the Navy had Alexanderson come to Bolinas and reconfigure the whole station to his system with the full embodiment of the patent. In other words, the antenna with the scalar function, not a velocity. The whole thing was built there because the space was so small. New Brunswick and Radio Central in New York had all the space in the world, but Bolinas was so small, and it was RC. What the Navy did is, once Bolinas, the plans were drawn up and things were ready to go in, the Navy formed the Radio Corporation of America to take over Bolinas and New Brunswick and be the rulers of radio. The Navy, particularly this Assistant Secretary of the Navy, Franklin Delano Roosevelt, decided we must even go farther with this and outlaw radio completely. And it was illegal to own a radio in 1919. Basically, 1919 is a signal year for the death of electrical engineering. RCA was formed. They formed a patent pool and a trust. Nobody could build tubes. Nobody could build transmitters. Nobody could do anything unless RCA decided it was to their behalf.
Is that the antenna right there, Bolinas?
That is the last antenna array to go up, which has nothing to do with the Alexanderson. All the Alexanderson and the Marconi stuff is in this book here.
You want to explain what you were looking at?
This is all garbage.
Okay.
It's dead garbage.
Okay.
It's, I don't know how. There's a lot of material. I could just go from page to page in this book. So why don't we just take a break now and then let's see. Well, how much? Thank you. Yes.
There was just a short gap between Tesla doing his standing lightning and him being on the streets, and I missed what happened, if you said anything about what happened in between.
Okay, well, in 1900 is when Tesla completed those experiments. And then by 1903, he had managed to get the money from J.P. Morgan to build a permanent plant in Long Island in New York. And then about halfway through the construction, Tesla was dragging his feet and spending too much time experimenting. And Morgan got the idea that this was going to be a self-powering system and just cut Tesla off at that point. And he was blackballed. He couldn't get any money to do any projects after that.
Threw him out on the street, so to speak.
So to speak, yeah. I mean, he had enough, rich friends. I mean, he used to wine and dine with the royal elite of New York City. There was nothing that the elite would want more than have Nikola Tesla for their dinner guest and have the opportunity to get a demonstration of his laboratory after dinner. People came from all over the world. Kings, queens, everybody. Everybody came to see Tesla's laboratory and have dinner with him. So 1903 to 1905 would be the period in which Tesla became a nobody.
Wow.
And he died in 1943. So that's kind of a long sentence as a street person.
Would you
Yes.
I'm sorry.
Go ahead.
I was just going to say, would you want to comment on things that were taken from his laboratory when the FBI...
Well, see, I don't know anything about that. All I know is stories. See, I only can go on things that I can,
That's fair enough.
Otherwise, I can just go, yes.
Could you elaborate on Tesla's impulse electricity?
Yeah, what it is the electricity changes at such a rapid rate in time that it gives rise to kind of like a shock wave condition.
Is that frequency dependent?
The frequency is imaginary. It's not in cycles. It's in neepers or decibels. So I'd have to get into mathematics. So that's one thing. Okay, you had a question.
I had heard that they withdrew their backing for him when he started talking about free power for the public.
Well, that's how the story goes.
Yeah.
But, I wasn't there. But obviously, there was a falling out. But see, the thing is, there's a whole direction. I mean, Tesla was taking this electricity thing and just going too far with it. And the Einsteiners and all that stuff was getting cooking about the same. I think Einstein got his start in 1905 with a paper on the photoelectric effect. And that photoelectric paper basically is what erased all those lines of force. Remember when I was saying how they were erased and all that was left was in the middle? But, that not being my particular area of study, I can't say exactly, how it worked. But Tesla's comments on it were pretty, well known. He just railed against relativity and the fact that you can get energy out of matter and all these type of things. It's never, and then you start looking at the way Tesla's stuff worked, and you start to see, well, if his stuff works, then he must be right on some level, because he was able to engineer it. It wasn't just a story. Nobody can duplicate Tesla's work. It's just nobody can duplicate it. I mean, it's possible for somebody to duplicate it, but as it stands right now with mind virus that exists in people's heads, they can't duplicate it because they don't know what it is that they're doing. They don't know what they're engineering. They're too busy arguing and fighting and making improvements. And the best you get out of is machines to make giant sparks. My contention is why build a machine when you can go out and throw some wire over the telephone pole and get all the sparks you want? So it's just, that's where it went. Big spark generating enterprise. And nothing else out of it.
Would you want to recreate his experiment where you got the minute-long, lightning bolt out of the ground? Would you want to try that?
I think the FCC would complain.
Well, in a different part of the world, maybe.
Well, as long as the Navy agreed to sponsor the project, so they can take the blame.
This might get folks upset. Okay.
Well, your whole .com reality might go into a meltdown. See, the thing is these type of waves can't be stopped by metal. So that causes, that's one of the threat aspects. That's why people would rather that none of this ever happen.
So it sounds to me, I keep going back to this, but it sounds to me like the Philadelphia experiment was a kind of an edge around this.
Well, the Philadelphia experiment was a story. Okay, nobody was at the switchboard that I talked to. I don't have any of the tubes or relays or sockets in my glom pile that I know of. Okay, I got a little piece of just about everything, including the space shuttle. But allegedly, the only thing that came from the Philadelphia experiment was the 89 beam power tubes made by RCA, but that's by Preston Nichols, and he's the disinformer geek. So he's the one that's pandering to this whole Philadelphia experiment thing and Montauk, mind control. And they're all paid disinformers.
Yeah, well, the mind control stuff is hocus pocus, but I'm thinking if you're...
Like I say, what I know is, okay, is I took the Minesweeper apart. Okay, I read all the books before the Navy pulled them out. A lot of it's classified, so, you know, the ship was obviously sanitized before it was dumped. And the Navy came back and wanted to share in the glom on their own vessel. And this Minesweeper and the mine evading technology is to make the boats invisible to magnetism. Okay, and how this is done is they have 3 sets of cables. Okay, they got ones that run in the X, Y, Z axis throughout the ship. Okay, and then the current, instead of running crosswise in the cables to neutralize the field, runs the same way. So these cables become giant magnet coils. Okay, and these all go to a classified switchboard. Okay, and in this classified switchboard, there's certain sensing apparatus at some part of the ship that feeds these coils with a variable current, okay, and neutralizes, like I was saying, with the car body, so that you would get rid of the lines of force, so you wouldn't have the inertia. It neutralizes the magnetic visibility of the ship. Now, exactly how it does it is a classified operation.
Is it done with AC or DC?
Done with DC. Now, if I was to do this for the Philadelphia experiment and somebody said, do it or die, first thing I would do, instead of making the current go in the same directions, I would make it all go opposite directions like it normally did, but I'd do it in such a way that it generated one of these type of waves I was talking about, and see what happened.
But if you,
and that would involve impulses and not direct current.
But if you're working in space, counter space, time, counter time, that suggests that at least you have like the beginning edge of like an entire Pandora's box of how to create sort of like vacuum loops in this.
Well, see, here's the thing. This is the reality that electricity lives in. Okay. Now, as far as anything else, like having people walk into something and appear in another world, or you know, physical mass or weapons, or see, the thing is, electricity exists in forwards and backwards time, and space and counter space, but that doesn't mean that the chair does, or the aircraft that they want to make invisible. You see what I mean? It's making that step.
But something inside a field would then appear to be outside those parameters.
Well, that's possible. See, that's all the stuff, that's where experimentation and research comes in. You have to experiment. You get the idea, you do experiments, and then you start to get results, you know, and then you learn a couple boo-boos, and maybe there's a big fireball, or, you know, something blows up, and $1,000 of transistors are fried, and then, you know, and then you try this, and then, you know.
Well, I guess my question would be if you...
Shortens your beard a little bit,
right,
and then you make another...
If you were like allowed to play in the lab, would this be something you might want to look at?
Well, I have my lab right now. You saw it.
Yeah. A larger lab. A much larger lab.
Well, it's, you know, I don't really know. You know, if I walked up to you and handed you $1 million and demanded you tell me what you're going to do with it, what would you tell me?
I'd probably say, let's talk in private. But I have
so, right now, what you saw down there and everything I described to you, that right now, that's my main. If I get any money, it goes in that direction.
Understood.
Now, the thing is, I would like to get one of these light bulb things back together again.
I agree. That'd be good.
I would like to get one of those back, because the last one I got built with the money from Reynolds and all that was basically hijacked from me. You know, I got a little small one I was going to put together for George, but somebody's got to be paid to build it. You know, but my workload is pretty full up right now with keeping that place operating. So, I mean, you know, when you have your own Navy base, you know, and you don't have any Navy funding and you don't have any Navy sailors, it's tough. So basically, I have my own Navy Electronics Research Institute, but it's just me. But, like I say, you know, you put the information in your head, you go experiment.
I might.
You should.
Okay.
That's what I'm encouraging. I want everybody to get out and experiment. I want everybody to read the books that I read, and if they want to learn, and do it. I mean, I documented all the references. Don't listen to me. Go to the references, the people I got it from, and learn from them. Otherwise, I got to bark myself silly trying to get this across to people when the experts, did write the books. But it's a lot. We're going to take you about 8 years. But, I mean, just the thing to start with is Steinmetz's basic book, Impulses, Waves, and Discharges. And he starts to work the concepts in your head. Get a copy of J.J. Thomson, Electricity and Matter, and just read them. But don't argue with them. See, that's the whole thing. Oh, no, we have this new concept. No, we don't have the new concept. We're talking about their concept. See what I mean? That's why the duplication is not possible.
Do you want to comment on the integratron at all?
Let me get a few more ideas, and then I'm starting to get an idea of where I'm going to go. Any more, anything people in particular want to know about? Yeah.
Just curious, what I've read about Tesla, there was comments that he thought his turbine was his greatest invention as opposed to his electromagnetics. Do you have any comment, or have you come across any of that in your reading?
Well, he was at that was around 1916 where he found the new way to make money. Came up with a new invention, so it had to be the greatest thing that he came up with. And he managed to get a space in one of Edison's power plants to experiment with it. And his personality pissed everybody off. And it just got back into the same situation again, and it didn't last that long. The turbine is only useful with his devices because the RPM's too fast. So all you can have is high-frequency devices. It's no good for 60 cycles a second, but it's great for 600 or 6,000 going up there. But 60 cycles a second, it's just, the thing's way too fast. That's the problem with most of that Tesla technology. The stuff just goes way too fast. Where it found its practical applications is in clog-free pumps, where the power, instead of going out of the shaft, is going in the shaft. And there's a big business in San Diego called Disk Flow Corporation, and they make their money using the Tesla, what you call a centrifugal pumps and turbines, and all these. There's classifications of machines. So any type of centrifugal pump or any of those type of things, the turbine, where the Tesla turbine is a centrifugal device. In other words, the liquid can't move exactly the same speed as the mechanics. Where a positive displacement device, something more like a bladed turbine or whatever, it tends to get locked a little tighter. Like I can take a centrifugal pump and I can shut off the output valve and nothing will bust. But if I try to do the positive displacement pump, if I shut the output valve off, I got a bust crankshaft or a connecting rod or a hole in a piston or something like that. So it's a kind of impeller technology, but being that it had no blades or discs or slots or any of the stuff you find in a conventional centrifugal machine, is the velocity's got to go way up to get the effects. And then the efficiency goes up accordingly. And then you hook that to Tesla's high-frequency electrical machines. Well, now without a gearbox, you got the speed to get your 50 kilocycles a second. Where Alexanderson had to have this horrible gearbox go in between the electric motor or the turbine to the generator. With the Tesla stuff, is just straight across, so the efficiency would go way up. So Tesla invented the turbine basically for his technology, but the pump came out of it. Because there's nothing for the boogers and the cigarette butts and all the stuff that when you're pumping the sewage out of the bilge, there's nothing for it to catch on. It just gets pulled right through. So that's its practical application, yeah.
Well, Tesla had this transmission turbine that I believe the term transmission turbine would indicate different diameter discs, and the smaller disc would have smaller RPM.
You're talking about a staged turbine.
Yeah.
The staged turbines are usually all on a common shaft.
Right.
So they have to turn at the same speed.
Well, yeah. Well, I was actually thinking on another level about the using the magnetics, electromagnetic thing. You've got a field thing going on there. Couldn't they incorporate electrics into that turbine?
Well, but then it's not a turbine. Then it's a motor.
Yeah, but it could be used that way.
Well, you're talking about compounding two different technologies
into
the same machine. So build one and see what happens. Okay, that's,
We have 11 people on the list, Eric, that'd like to attend classes if you were willing to teach them with them.
okay, well, if I can figure out a way to get over the big hill once a week.
Or once every other week,
Yeah.
whatever frequency you like. And I'm wondering, would the people be more interested in experimental work, building stuff, or in the electrical theory?
Everything.
Yeah, it's just everything.
Okay.
Yeah. Whatever people want to do. If you got the money to go buy parts, you can't find this stuff anymore. If I got the last glom, it's gone. Tubes I use in my equipment, there's no money in the world that'll buy them, and nobody can make them. Nobody can make anything that works anymore. It's over. Babylon is here.
Why?
Well, I don't know why. That's just what happened. Maybe the Bible says why. Read it and see. Okay, so, yeah.
Are the Russians still making vacuum tubes?
Yeah, they're the only ones. Well, actually, Sweden's making tubes too, and all around that part of the world. And I've seen the recent tubes that come out, and the quality is just stunning. And they're keep the see the tubes are real popular in the audio business. So there's always a market, big market, for tubes. And being that it's a fad, it doesn't matter if they sound any different or what the thing is. Everybody just wants them because that's the fad. It doesn't matter. It's still the same old 1928 RCA circuits or any of that. It's just people want to go back to that. This has really not that much to do with the difference between the tube and transistor. What it is, it's the tube and transistor circuits are different.
So those tubes, the modern tubes, are adaptable to what you want?
Well, the thing is I had to... I use the vacuum tubes either kind of, how would you say, as a sculpture. In other words, when I build equipment, I go for a certain archetype of a certain era. So the vacuum tubes are used where you could use a transistor. It wouldn't make any difference, but I want to stick with that era technology. But my Earth signal receiving system has to use these special tubes that were designed by a telephone company. That have super amplification capabilities and they don't wear out. And those tubes are priceless. Some of them go for $1,000 a piece in the audio business. The reason for using the tubes is these earth impulses are so intense. They last for very short periods of time, but they're so intense that they tend to burn out the receiving devices if they have semiconductors in it. So, and then my antenna field is in a major lightning zone. So, I have bolts of lightning dancing around me 2 or 3 days out of every summer. And the transistors, you hook transistors to that antenna field, and they're history.
That's what happened to Joe Tate before the 1989 earthquake with his apparatus that we talked about here. It was all transistors that all blew out.
Yeah, well, I mean, when you were down there, you saw the pulses on the scope. Those things have a very high amplitude. They don't last for long. It makes them hard to see.
I think the term is toast.
Yeah.
Yeah. Well, it blows a hole in it. There's not enough average energy to cook. Blows a hole in the semiconducting material. Just like a bullet. Just cracks it. So it's just like, a lightning discharge doesn't, the pulse tends to want to break things more than melt them. Because it's just so much at so little of a time. That's why it produces that, detonating sound. So the frying would be more like, if there was something continuously going. But from what the old descriptions of the telegraph, obviously these telegraph lines were picking enough stuff up where the Aurora Borealis appeared in the telegraph office. See, the Aurora Borealis is not a normal light bulb glow discharge. There's something funny about it. And that's never been addressed. It's not something that you can create by making sparks between two plates.
Is it more like Northern Lights?
Well, that's one about the Northern Lights, but there's something funny about it. There's something that doesn't add up. It's not just a neon bulb glow discharge. There's something about it that's different. The guy that got into this is Jerry Vassilatos. Have you ever heard of him? No. Jerry Vassilatos did an interesting thing. So I gave some lectures in New York or something about, I forget what it was. He decided to start experimenting. And then do the same thing I did. He went to New York Public Library and he went to all the old books, all the way back to Ben Franklin, and the original, writings about Galvani, and, where you had to know the Old English letters, where the S's and the F's are the same. And he went back to the primitive reality and photocopied all of it and made it in a sequential thing consisting of 12 volumes of about 200 pages each called this a compendium. And the entire history of electrical science is in these photocopied library papers, or the photocopies of the books. And it's incredible what these people were doing back then and the concepts they had. So I went, for months straight studying these things. I started getting all these flashes. And that's why I returned to the Alexanderson system, because I found out from his photocopying and digging that what I learned from RCA about the Alexanderson system was completely false, including the plaque they put on the Marconi building that says that RCA finished it in 1920 when Marconi finished it in 1914. So do people want to know a little more about that Bellina station? I can get into that. Or let's see, there's a couple other, you want to know about the integratron, but that's getting into, that's just a little farther. Yeah.
I'm curious about the history of the concept of just the term scalar, and then how it is alive in your own particular thinking, if it is.
Scalar, by definition, the scalar is that, let's go back to the Heaviside Telegraph Equation. So I'll give all the terms. The Soviet scalar technology hoax is mainly the work of an Army colonel, I believe, by the name of Tom Bearden. And it's exactly what it was. It was a hoax. It was designed basically to throw so much confusion into Tesla's work and to absorb up all of the Tesla Society meetings and the psychotronic meetings and everything, and create this paranoia and fear, and then make money of selling devices to protect people against the non-existent waves. Because scalar means there's no wave. So if I say scalar wave, it's kind of like saying an Israeli-Palestinian. I mean, it's one or the other, If you can't exist. Scalar is that part that doesn't vary. That part in which there's no wave. That's why it's called scalar. It's a quantity with no direction in space or time. No divisions, no variation, no distribution. It's that part that's everywhere the same. A good example would be atmospheric pressure. Okay, if I take a barometer around this room and out in the street and all that, the barometer is always going to read, let's say, 30.1 inches. Doesn't matter there, here, any of that. Okay, I could take it up to Haight Street. I could take it down, as long as I compensated for the altitude. It's always going to be that air pressure wherever I go if I can maintain a certain altitude. That's space scalar. There's no variation in space. But if I graph the atmospheric pressure over a week, I get these like sine waves. So the atmospheric pressure is scalar in space in the neighborhood. Obviously, if I go to, Eureka, it's going to vary. But in our area, it's scalar in space. But it has a wave in time. Does that give you kind of an idea what the word scalar means? It's that quantity it's like DC. If I take an electrical oscillating system and it's got impulses and it's got oscillations and alternating currents, there'll be one quantity of electricity that doesn't vary. While all the rest of it's going higher or lower in this way and that way, there'll be one constant that will be uniform throughout the whole circuit. That's the scalar quantity. So what Bearden did was use the trick to take, there's two types of waves. There's longitudinal and transverse. This is the whole bugaboo, and this is what the Einstein thing is disrupted. And this is the forgotten part of Maxwell's. Maxwell considered two types of waves. One is transverse. Okay, a transverse wave is like waves on the surface of the ocean. Okay, there has to be a boundary. And the motion of the matter or the ether or whatever deal you're dealing with is always at right angles to where the wave is going. Okay, and it's slowed. It tends to circulate and stay in one area and then move on to the next and move on to the next and move on to the next. That's called a transverse wave. In other words, the energy is sideways to where it's going. You understand what I'm saying there? Does everybody kind of get that? I guess? Okay. Now, a longitudinal wave, if I set off a load of dynamite underneath the water, okay, and then another place underneath the water, okay, it's a shock wave, and that other place gets it real fast. There's hardly any delay at all. Okay, it's right there, and it'll blow your eardrums out. Okay, and the surface, initially, there's no evidence of this until the turmoil gets going. That's a longitudinal wave. Okay, the material or the energy or whatever is going the same direction that the propagation's going. It's in line. Okay, now if I take a 10-foot rebar piece, a half-inch rebar, okay, and set it on little deals so that it's free to kind of move around, doesn't fall to the floor or whatever, strings. Okay, what I can do is I can take one end of that rebar and hit it with my hand, and a little wave will whoop sideways, just like a transverse wave will go from one end to the other, right? I mean, that's like you do it with a piece of rope or string. The other way I can do it is I can hit the end of the bar with the hammer. You can't see that wave. It's instantly at the other end. That's the longitudinal wave. You see the difference?
What is a wave of compression?
It's a wave of compression and expansion.
The actual medium of transmission for delivering the force.
Right.
And the other is transverse, involves some other process.
Yeah, so it's a transverse wave is kind of operating out of the wave realm. It's not really a very effective wave. Now, if electricity is supposed to be transmitted through space electromagnetically, the first complication that comes to mind is where's the boundary? There is none. So Tesla said there were no transverse waves. It had to be longitudinal. So right there, then that kind of just messes everything up. You want to comment on that?
Yeah,
sure. What are you thinking over there? What's that?
Electromagnetic propagation lies in those two, let's call them perpendicular.
Yeah, perpendicular, yeah.
And the effect of one is having an effect, or seems to have an effect on the other.
Well, the thing is with electricity is one aspect of it is denial of the other. Okay, well, here's what I'll do, is I'll take an electrostatic condenser, okay, a capacitor, Leyden jar, whatever, okay, and I put an electrostatic field in that, okay, and it's got its plus and minus, and this field's in there, and it wants to pull the pieces together and all the regular stuff, but it can't do anything, okay, it's stuck. Now, if I take an electromagnetic inductance coil, which has a similar physical volume, but it has a complementary way of representing itself. In other words, the capacitor tends to work by dividing up the metal like this to get in between, where the coil does the dividing for enclosure of a space. Okay, now this device here, if I have current flowing through it, okay, it has a magnetic field. Okay, in order to have a current flowing through, of course, it has to be short-circuited. Okay, if I'm going to maintain this electrostatic energy, and so it doesn't go away, this has to be open-circuited. If I'm going to maintain the magnetic energy, it has to be short-circuited.
But each of them can...
Well, let me finish. Okay, so this represents energy storage. Okay, the energy being...
kinetic.
Being the inductance. Remember we talked about inductance? Okay, inductance multiplied by the current squared. Okay, and that's in watt seconds. It's energy. Okay, it will light a 1 watt light bulb for 1 second. Okay, now the electrostatic energy is exactly analogous. It's the capacitance and the square of the electrostatic potential that's associated. So if I got 1 amp here, and I got 1 volt here, okay, and I have 1 farad here, and 1 Henry here, then I get 1 watt second, you see what I mean, of energy. Okay, now, if I take the capacitor Okay, and I take the coil, and the capacitor is full and the coil is empty. Okay, because now I've had a situation where, do you see how these two things are conjugates, that one is the denial of the other?
It takes a lot of electric
Well, let me just keep going.
If you ask how I see it, the inductor requires a lot of electric potential stored up in the condenser to start a current flow.
Well, the thing is, we have the current flow.
Well, in the second picture, you have no current.
Well, I'm getting to that.
Oh,
Exactly.
So it's empty. You said it's empty.
Yeah, the inductor.
It's waiting for all that
the inductor is
electric
empty. Okay, the capacitor is full. Now I go like this. Now I have one is the denial of the other. Okay, this thing cannot maintain a steady electrostatic field because it's shorted out by the inductor. But the inductor cannot maintain a steady magnetic field because it's open circuited by the capacitor. So the electricity is trapped, but it oscillates. So if I take the inductance and the capacity, that gives me 1 over the time squared of the oscillation. So we have these two aspects of electricity, and by themselves, nothing happens. Okay, but as soon as we combine them together, now we have an electric oscillation. And the electricity will continue to go back and forth for eternity until something takes away part of the field or something eats part of it up. So this is the electrical situation is based on this duality. Okay, it's called conjugates. If I have a glass of water, okay, and the liquid level is here, halfway up, not only is the glass half empty, but the glass is half full. And you can't have one without the other. It's a conjugate relationship. When I have an electromagnetic field, okay, and the magnetism is going this way, the electrostatic has to be going this way in an electromagnetic field. Now, in a Tesla field, it's completely different. In the Tesla field, the magnetic line's longitudinal. The magnetic lines of force and the magnetic lines of force operate in a line. Now, in this case, where the propagation of energy is at right angles to all of it, the propagation of energy is along the line. So this is a spatial situation, and this is like a counterspatial situation. This type of electric wave exists in a lot of electrical equipment. It exists in all your capacitor banks. It exists in all your transformer windings, your motor windings. Anything where the metal is divided up onto itself, you have these longitudinal waves. But they're not put into the calculations. Because the thing is, if you're designing a capacitor, you're designing it to be a capacitor. If you're designing a coil, you're designing it to be a coil, so you always eliminate the other field as being too small to be concerned with.
Because there's a huge one.
But what Tesla did is Tesla took the coil, okay, which has capacitance, okay, and what he did is he found this frequency where the capacitance of the coil itself matched the inductance to what's this called a resonant process. And at that point, the coil turns into this monopolar transformer. It's that simple. All you have to do is find the frequency of the coil of wire that if you connect it to the output of your radio transmitter, your alternator, or whatever, and the other end is grounded, okay, when you find the frequency where the energy of the magnetic field equals the energy of the electrostatic field in the coil, okay, this terminal doesn't have to be connected to anything. That coil, okay, terminated here. You have your alternator here and grounded. Now this coil will transmit into the ground without requiring another terminal. As long as that energy balance criteria is met, any solenoidal coil becomes a monopolar transmitter. It doesn't take any fancy equations or special turns, or obviously you can optimize it.
It's monopole because the other end is in the ground?
The other end's in counter space, inside the capacitance. If I want an electromagnetic waveguide, I have to have a boundary of metal conductors. That's why when you look up on the telephone pole, there's always a multiple of conductors, typically 3, to establish the boundary to confine the electromagnetic waves. But the problem with 3 wires and 3-phase is electricity is basically a 4-pole phenomenon. So now when you try to make it go 3-pole down the lines, not only do you have the transverse electromagnetic wave that we discussed, But the fact that there's no more plus and minus, but it's partially in between because it's a triangle now instead of a cross, is you have a longitudinal current going sideways between the wires. So the power flow down a three-phase power line is no longer electromagnetic, but is a complex electric spiral. And Steinmetz tried to crack this and backed off from it because it was a little too far for what was going on. And what this does is this triple wire configuration uses the least amount of metal to carry electricity from point A to B. 4-phase 4-wire, 2-phase 2-wire takes more metal. For some reason, this triple phase, no one's ever been able to explain it, takes the least mass in your transformers, your motors, and your transmission lines. For some reason, the mass quantity in the electrical system has a low in that. And it'd be interesting to sit down and analyze that.
You mean for efficiency? That is four conductors.
Yeah, in other words, 3 wires will transmit the most electricity of any electromagnetic boundary phase type situation. You know, 6 wires, 4 wires, 2 wires, 3. Not 4. It's got to be 3. See, the thing is these electrical pioneers, they got it to the point where this stuff was mathematically and what have you. It was there to work with, and then it stopped. So basically what needs to be done is to go back and pick up where these guys left off. What I did is the mathematics was never complete. The system of units was a mess. Okay, the physicists started putting 4 pi in the equations where 4 pi didn't belong. So what happened is then when you had your normal 2 pi, which always appears in almost all your alternating current stuff, the 1 over 4 pi c squared cancels it out, and it disappears out of your equations, and you lose the vision of the circle that you're working with. You can see what I'm saying. Cancels itself out. So what Heaviside did is he railed for what was called the rationalized system of units, to get rid of all the scales and the magnetic monopoles and the points of mass that can't possibly exist and the little gyroscopes and all the stuff that Maxwell just twirled the thing into the nth dimension with, and make it into a basic, you know, A plus B equals C type of situation. Was to get rid of all the complexity. So let's see, anybody else got any other, looks like we're about petering out here. Okay. Yeah.
Maybe you can go over the integratron real briefly.
Okay, well the integratron is, that is what I regard would be the physical manifestation of the scalar transmission. In other words, that's the device that if you have one on Mars and you have one on Earth, if you go in the one, you walk out of the other. That's, when I studied that.
Was there one of those in Lancaster?
No, there's none of them around anywhere, really. About the time I figured out how to make it all work and found that all the materials were there and the whole thing was kind of set up like a Heath kit, and I managed to get all the junk and the weirdos and everything out of there and all that, well, lo and behold, the guy that had the property lost it and everything disappeared. So
George made a really great comment. I thought was brilliant. No, he was talking on the phone one night and he said, you know, Charles, this reminds me of Carl Sagan's Cosmos. The exact same story.
Contact.
Contact, I'm sorry. Contact. Contact. Same exact idea. Eccentric billionaire funds this project. Guy in desert gets these plans from somewhere, and it was really meant to be a portal.
Rotating device.
The rotating device, exactly. Which I thought was a great thing.
With Tesla.
Because I actually met Carl Sagan once, very briefly, and I got the impression this was a very bright guy who was also very confined. And he was being extremely careful about what he could talk about or not talk about in this very broad realm that he was communicating to the outside world. So I thought it was interesting insight, but maybe share.
Well, this thing about the integratron is my theory. Okay, I mean, I didn't, I've never built anything where you walk in the one box and you walk out of the other one. But the thing is what I found is this integratron structure had to be space scalar. If you analyze the electric fields that appear with the key to the integratron was it had a pair of coils, 90 turns, and 1 mile of wire on the ceiling of the first floor. One went one way in copper, and the other one went the, got this right? Yeah, the other way in iron. 10 gauge copper, 14 gauge iron. soft iron wire, all insulated. Okay, and there's 4 spark gaps that were remote controllable by compressed air and plastic pipes, so you couldn't have any metal in here to short this thing out. The whole thing was charged up with 100,000 volts from the thing that spins on the outside. Electrostatic generator, and the dome is covered with metal, so that's your capacitor to space. And this thing is inside the flux underneath, and these spark gaps fire into the copper and iron, which juncture in the middle. They fire, 2 of them fire into the ends of the coil, and 2 of them fire, I forget the exact diagram, but 2 of them fire into the dome. And so it's this electrostatic energy is being pulsed into this coil. Okay, where they come together in the middle, there's kind of like a capacitor and a column. They drop things down. And what goes in there, I don't know. But when you analyze this, what it comes out to be is it's a strictly space function. There's no space variation. So what I did is I did some experiments, because Van Tassel was always talking about caduceus coils. That's a coil where you got turns one way, and then compounded on it is turns the other way. And what I found is, if this is coil A, I might have it wrong, but from the outside it'll look right. This is coil B. Okay, if I connect them in this way, okay, at these terminals, because this thing will resonate in an inductance capacitance oscillation, but the amount of capacitance, the amount of inductance here is all screwed up by the fact the turns are wound backwards on each other. This thing will oscillate at a frequency of roughly 100 times beyond the wavelength of the wire, and with a precision that's so intense it makes you wonder, like, what's it locked into? And somebody had tried this idea and came up with some UHF TV antennas built on this principle, and their receiving range apparently is fantastic. So this is the key to the integratron, is to create this space scalar condition, where it exists only in time and it doesn't exist in space. And that started to give me the idea that maybe this thing wasn't for healing people, but for making people be able to go from point A to point B. And then the Alexanderson space scalar concept popped up later in my study of RCA, and so that kind of serves as again, as an analog to this space scalar situation. So if somebody wants to start experimenting with, building a transporter, it's not a matter of taking the molecules apart and making them reappear at another end. That would be a hideous project. Doesn't make any sense. The best thing to do is just simply erase space out of the formula so that you're both places at the same time, and then make the switch, turn one off and leave the other on. That's how I perceive the integratron. Allegedly, how many people here know what the integratron is or heard of it? Okay, well here's the integratron for the people that don't know. Okay, there was an old German guy that lived under a rock out in the desert. Okay, and it used to be a place where things would appear in the sky. It's called Giant Rock. It was a giant rock. Old German guy lived under it. It was in San Bernardino County. Okay, this was during World War II. Okay, the German guy had a big shortwave antenna, and his, Atwood Kent, with all the tube radios and all that. So for some reason, the Riverside County Sheriff's Department decided that he was a German spy, and they killed him, blew him up in his hole. Well, Van Tassel had been coming out to visit this guy to hang out, because that's the place to see the weird stuff that flies around in the sky at night. So Van Tassel just inherited the place because he was there and nobody else was, and it was the deep desert. And he was an aerospace worker for Howard Hughes on a personal level. So he was into the whole kind of, spacecraft and all these. Because Hughes came up with some really bizarre stuff you don't normally hear about. That's probably why he was put out of business. Hughes was deep into this stuff, experimenting and what have you. He was a genius of his own right. So apparently Van Tassel and his son-in-law were approached by a spacecraft. Okay, and the aliens gave them instructions to build this integratron device. And they went forth and started building it, and started having these conventions, and turned the whole thing into a dog and pony show. So the space people cut them off. So they carried on the dog and pony show until eventually everybody kind of died off, and that was the end of that. And then the geeks ended up with it. So you had the Purple Gay Indian Club, and then you had the bikers, and I don't know how much meth might have been cooked there in various phases. It looked like it might have been a lot of LSD. So my job as the exorcist, that's one of my positions in life, is I go in and I run the devils out. So without a shot being fired, I got rid of all of it. And then once all the junk was gone, and I was introduced to all the people that knew Van Tassel, and I read everything he wrote, I went around and found all the little pieces here and there. I found once the mess was cleaned up, here was a Heath kit. The boxes of wire, the aluminum for the dome, it was all lined up right there on the floor, ready to go.
That's big rock right there.
Giant rock.
Giant rock, yeah.
So what I did is start to put it together, and with 6 months, gee, I wasn't there anymore. And all the equipment disappeared.
And they filled in with concrete as well. They made sure.
Well, no, the dome is still, this has been, the
exactly.
Park Service, there's no more under the rock.
Right.
And then the rock split in half. I think that's what you're seeing there as the piece broke off.
That's right.
So we decided we were going to plant some rumors around there that there were some people buried under the rock and name it after the people that didn't really exist.
Yeah.
Something derogatory, because that place now is just a haven for motorcycles and I haven't been there in 20 years. You can't see the stars out there anymore anyway. So that's basically what the Integratron was about. So now these people have it under lockdown, just like they have the Bellina station under lockdown, and everything else under lockdown. And it's just become another self-worship temple. So that's the end of the Integratron. But that doesn't stop people from building models and experimenting with this stuff.
How are you spelling that? Integratron?
Oh, I'm not good at spelling things off the top of my head.
Integratron.
Like it sounds.
There's a website, integratron.com.
Yeah, the website is the enemy.
There's also a retro UFO thing coming up in July or something, I think. I'm not sure when it is. There's some event there.
You can find the website on KPH, the station in Belenis, too, and you can see all the people that are responsible for screwing all my stuff up. Because basically all their website is pictures of themselves standing in front of equipment.
That's the Integratron.
So you can find the most compromising picture you want for your voodoo festival. I encourage you to experiment. You couldn't find a better group.
Speaking of experiment, you flailed a cord or something about through a magnetic field and counted like different speeds.
No, what I did is I took a relay coil, which had about 1,000 turns of wire in it.
Very good.
So it could absorb up the magnetism to the point where it would drive the headphones. It had a magnetron magnet. I took the coil and moved it around the magnet, and I could hear the magnetic field scraping through the coil.
There would be
Scratching noise.
Okay, so
the lines of force.
Which you interpreted as like real sharp transients, saying this is not a smooth continuum.
No,
These
it's
are really
fibrous.
Sharp boundaries.
It's fibrous.
You could do that again, probably.
Anybody could do it.
So that would make a great introductory class lab.
Anybody can, that's the whole thing, is to experiment. What I did is, I didn't have any, college professor or anything. I was just a kid. Main thing I wanted to see was big sparks. So how's the little 6-year-old junior going to get big sparks? So, it's a different way of studying when you're a kid. You're going after more, I don't know, you're better off that way because there's no preconceived notions. That's why Tesla and all these people could make these discoveries, because the mind viruses weren't established yet. They could move freely. There was no unit of the Henry and there was no unit of the Farad when Tesla built his Colorado Springs project that had just been developed. So when you read these guys' books, you have to go use their system of units, CGS system of units. The volt and amp, see, all those things are all recent ideas. But the original guys weren't hampered down with all these definitions like now. They were able to move freely in it before it became rigidified as a corpse, like electrical engineering has become today.
We're at 6 o'clock.
Okay. I'm spent. I think everybody's got a brain full.